το, ένα. Δουλεύει,
Ωραία. Good morning, everyone, and welcome to day 2 of PyCon Greece 2025. We hope you enjoyed the first day. I attended some talks, you met some new people, had fun at the social event. We can tell from the very refreshed faces this morning. So today is another day full of inspiring talks, hands-on workshops, and a lot of surprises. One more time, we would like to thank our platinum sponsors, Yodec and Elastic, for making this event possible. So another round of applause, please. Okay. As part of today's surprises, some announcements. We're going to be hosting an exciting raffle at the closing session today, where our silver sponsors, Pact, is going to be giving away 6 hard copies and 5 ebooks. And JetBrains is going to be giving away 5 licenses for their products. Also, you still have time to join Elastic's quiz for a chance to win some prizes. So please pass by their booth to get more information and get involved. Now, it's my honor to introduce today's keynote speaker, Grigoris Maravelias. He's an astrophysicist whose passion for massive stars, astronomy outreach, and Python is truly out of this world. With a PhD from the University of Crete and research experience across Czechia, Chile, and Greece, he's using machine learning to unlock the secrets of the cosmos. As a co-founder of the Summer School of Astrostatistics, a Python educator at the University of Crete, and a champion of science education through Periastron, Grigoris, in his own words, brings together code, starlight, and community to make science accessible and impactful. Please join me in giving a warm welcome to Grigoris.
Okay, thank you. So, good morning, everybody. I would like, first of all, to thank the organizers for giving me this opportunity to stand here in front of you. I'm actually honored by this. And what I think is that I'm going to represent my own community, astronomy, in front of this amazing community. And we'll see where we actually have a cross match. So, I'm an astrophysicist. I have actually used a lot of machine learning and statistics in my work. I have also been training a lot of people into these tools, and I have a lot of experience with science outreach. And Periastron is an organization that can host all of this above. So this is just a very short introduction of what I have been doing. So in this talk, what I'm going to do, I will try to showcase how Python has actually transformed the field of astronomy in the last 2 decades. So usually, or not usually, but oftentimes, I structure my talk around the title. So I try to break down the title into terms and explain the terms. So the first is actually very easy. Python. We are in a PyCon, so fortunately, I don't have anything to say about Python, right? Let's go to the next one, astronomy. So I believe that everybody in this room has already an idea of what astronomy is. But I would like to frame it with you together now. So what I did, as a modern person, let's say, I asked Wikipedia and Perplexity, right? What is astronomy? They came back with these answers. Don't go through the text. I will help you highlight the important points. So, what is astronomy? First of all, it's a science, right? One of the natural sciences we have. What does it study? Celestial objects. Objects and phenomena that are outside Earth's atmosphere. How does it do it? It uses mathematics, physics, chemistry, biology, computers, right? And another key point of astronomy, it is one of the oldest sciences. Why is that? I believe that most of you have been already in a beach during the summer or in a remote area. Even if you didn't do it this summer, you have done it in the past. So you have looked up in the sky and you saw something similar to that, right? This is the night sky from Athens to night, but okay, it's not possible to see that because of the light pollution. But this has been the view of the night sky more or less for millennia. Since the beginning, humans, they would just look up and they would wonder, what are all these stars? What are all these lights? Right? And these questions about what is in the night sky would continue. With time, what they did is they try to actually connect this, they try to connect this with their own experience, with their everyday life. They try to find patterns. This is not very visible, but actually they try to connect the night sky with what they knew, the local stories or the myths. And actually, this survives up to today. The official names of the constellations are driven by the ancient Greek mythology. Okay? So, this has been the case for thousands of years. At some point, at 1600, a guy named Galileo turned a telescope to the sky that changed the view of the night sky. He discovered new worlds. Like, since then, the advance of technology, both telescopes, instruments, computers, along with the advance of the science that accompanies the study of the night sky, has resulted in more and more amazing discoveries. Fast forward to today, this is an image, possibly the state-of-the-art of image that we can produce from ground-based telescopes. This is the facility known as Vera C. Rubin Observatory. It initialized like a month or so ago. And what you look here is part of the Vigo cluster of galaxies. So you can see these galaxies, spiral galaxies, some fainter ones, and actually what you see in the background, you may see a lot of point sources. Some of them are stars, but most of them, hundreds or thousands of them, are what we call background galaxies. They are so far that we cannot resolve them. This is about 55 million years ago. You know what that means? That when the stars started, there were no humans here. This light traveled 50 million years to come here. Actually, human beings didn't exist in Earth back then. Let's come closer. This is an image of what we call Trifid and Lagoon Nebula in our own galaxy. You see amazing details about the gas and the dust in this region. These are regions that form new stars. And if we go a step, not a step, possibly many, many steps outside, we can take a look of an image from James Webb Space Telescope. This is the state-of-the-art of space telescopes out there. It is the largest and the most modern telescope right now. And this is the image of Stephan's quintet. This is a small group of galaxies that actually interact each other. You have one of these galaxies going through this one, and you have this, what we call collision of galaxies. And what you see here is amazing details about how stars and gas is moving through the interaction. Right. What else have we achieved so far? So, take a second. This is a busy image. Eyes on me, please, right, to help you, guide you through this. So, what we have been observing so far is the universe in the optical. This is just a very small part of the electromagnetic spectrum. Over the last 100 years, we have developed instruments and technique to look at different wavelengths. So if we go to infrared or radio, we see cooler stuff. When we go to the other part, let's say at UV or X-ray, we see hotter components of the instrument, of this galaxy, for example. So what does this tell us is that we have a different views if we look at different parts of the electromagnetic spectrum, and beyond that, if we include gravitational waves lately. So in modern astronomy, we need to take into consideration all possible information from all these range in order to understand the universe and the objects we are dealing with. Okay? So, good. That's a definition, more or less, of what astronomy nowadays is. I have put this in. So, what does it mean? How Python is included in this process? For this, we need to define first what an astronomer does in his everyday life, right? So, for this, I have put a small quiz. If you are willing, we can actually, let me see if this, I hope this is going to work. No, first, I will have to put this. If you open the QR code there, then you have 3 fields. You can put in what do you believe that an astronomer does. Whatever you think, verbs, nouns, whatever. And let's see what will be the outcome of the word cloud. I hope it does work. Is it ready? Ah, okay, so perfect. It works. Let me return back to the QR code for everyone to also be part of this. Good. I try to see if there are any other phones. There are some. You can continue. The tag cloud will keep generating. Time for me to hydrate a bit. Good. So, let me see. I can already see observe as the main keyword. Observes, study, analyze, measures, what else? White papers, thinking, look at the sky, assumptions, study galaxies, universe. Nice. Research, not astrological predictions. Cool one. Thank you. Takes picture, discover Python, yeah. Too faint, it will become bigger with time. Good, so. Yes, thank you. Thank you, yeah, indeed that was the free version. It was only for now. Thank you. Indeed, so one of the main keywords was observe. That is correct, right? We do observe. So, this is a fellow colleague observing through a telescope. He is an astronomer, indeed. However, when we talk about astronomy in profession and research, we actually do something like this, right? We go to the observatories and we use a lot of computers in order to drive the instruments, control the telescope, and this is actually the acquisition time when we get the observations. Then we have a step where we need to do the data analysis. Right? This means a lot of hours in front of a computer trying to dig into the data and understand what is going on. Okay? I tried a lot to break down this into a pie in order to showcase what are the duties of a professional astronomer. So take this with a grain of salt because there can be differences. For example, what I saw here is that a guy that doing a guy or girl, of course, that does observational astrophysics, right? So what would be the responsibility? First of all, it could be some administrative duties, peer review, teaching or mentoring, depending on the level, publishing. This is one of the mandatory things. Then you have to collaborate it locally with your group members or the institute members, and of course internationally. You have to keep updated with literature, writing, finding proposals, and trying to develop your own career path. And then you have a big part of the pie that has to do with observations and analysis. The actual observing part is kind of small, I mean, unless you are a support astronomer in a telescope, or your project is critically based on observations, so then you spend a lot of time at the observatories. These can be up to 10% of the time. So we do observe, but it's not the whole portion of what we do every day. The majority is actually around this. Actually, in this part, data reduction, cleaning scientific analysis, probably maintaining, developing simulation for people that are doing theory. They're doing a lot of simulations, and they're using the appropriate software. And, of course, a lot of sitting back and trying to interpret what you see, right? Good. I also try to break down this process of data analysis into a flowchart in order to see how this is done, what are the components of this process. So we start first from data acquisition or collection. Data acquisition means that we go to a telescope, right, and we get the images or the data. Query means that we have a survey that provides images or data, and we query the database. Okay? The form of data can be anything from images, catalogs, ASCII tables, measurements, anything. So, depending on the file types, we do different things. If we have images, we have a pre-processing. For example, this is, without being too technical, we need to correct for some errors in the images and to calibrate these images. Then, if we have data, we have to do perhaps some mining, we have to do some cleaning, we have to probably combine with other surveys. As I told you, we need to look into different parts of the spectrum, so we need to gather information from any possible source. And if you are working with synthetic data, this is a bit simpler at this step, because you're actually using a model, you're producing your data, and then you progress with the analysis. So it's, you don't do something with the processing of the data because you are generating the data. So you have collected all of this, you have done some pre-processing, and then you actually enter the true analysis step. That is the place or the moment that you try to measure things, whatever it might be. Fit, probably, some of your data in order to understand what they are doing. And quantify uncertainties. This is a very basic step in science, especially in astronomy. Then, after that, you need to interpret the results. What does it mean? Is that you need to compare either with theory, with a theoretical model, or with previous studies. How does my data, my results, compare with what X and Y person did in the past? Is it better? Do I see something different? Why? Actually, the answer is what's new in what I'm doing. Why am I doing that? And then we have the final step, which is to present this to some colleagues, to get some feedback, and of course, to publish, or perish, as we say in this field, unfortunately, your results, right? Good. Within this scheme, do you see that Python fits some of these or any of these boxes? Obviously, I think you can see many, many parts. Data cleaning, filtering, pandas, right, NumPy, interpretation, analysis. You can use visualization tools, anything, Matplotlib, Seaborn, right? Fitting processes, okay, scientific Python, for example, machine learning approaches in order to make predictions, classification. Query, you can use any query. Okay, you can use SQL, indeed, right? But definitely you can use a lot of Python routines that are provided in order to do this. So as you see, there is a lot of room to exploit Python. And this is actually done. So below the main title, I have put this phrase, through a slight personal perspective. So I will just enter now my personal experience through this path. I started my PhD back in 2010. Back then, I didn't have any really programming skills. Have you ever heard of Pascal? I didn't expect that. Okay. It was back in my university years that I learned programming in this language. I had some experience with C, but I wouldn't consider it really something like a tool. At least what I was doing before astronomy, I was working with Origin, if you know, which is something like Excel. So when I entered the astronomy field, the landscape was something like this. We would work with Unix systems, either MacOS or Linux distros. Fortunately, I was working already a few years with Linux only, so it was easy for me. And there was a lot of shell scripting. We would use a lot of bash scripts to do the analysis, and of course to install everything, all the necessary tools, which was a pain, some of them. And you would do a lot of manual operations with awk, set, if that tells something to you. And there were people using IDL, which was a scientific programming language that had a lot of astronomical routines written on this. The problem with this language was that it was proprietary and it had some cost. Okay, not significant, but you had to pay. Then there were some open source packages. One of them was Starling. Do you see the date? They started developing that in 1980s. And when I was looking about the story about this, I found this brochure. This brochure dates back to 1994, right? What you see here is an image, and in this image, I don't know if you cannot read that, but what it says is that this software has managed to identify the sources automatically, right? And these are not cycles. You can see that there are some ellipses, for example, that follow the shape of the object, and they made some flux measurements in this case. That was done in 1994, okay? Some of you were not born, and if you were born, probably you remember the floppy disk of 5 1/4, right? So, astronomy has pioneered some things, especially with respect to data reduction and software. Good. Now, another tool back in the time, which is still heavily used, is DS9, which was a visualization tool. This is an image of the tool. I will not go into the details. What you see is an image. This is a raw image of one observation. I don't remember exactly what it is. It says from Ogle in the Small Magellanic Cloud. Anyway, whatever. And you can see what you can do, like highlight some pulses and measure the distance. This is just to show you an image of DS9. Then we had many instrument and telescope pipelines, which were custom. And there was also what I could call the astronomical tool, what is famous as IRAF, the Image Reduction Analysis Facility, which was a general purpose software for the reduction and the analysis of astronomical data. That was also developed in the 80s. And it has been, and actually it is in use up to now, right? The official support has decreased since 2013, but it is maintained by some community members. And this is an image of IRAF. This is a command language that tries to do all this processing, and this is it uses DS9 to visualize, for example, this image of the galaxy, and there you put a cursor and you try to measure, for example, what you call, probably this is the center of the galaxy, and you try to measure let's say, the flux density there. And this is a window that you can define some parameters. Okay, all of this was done manually back in the time. So, I needed something else to work with. I needed some automation. I needed some flexibility. And also, I would like to work with something which was open source. Okay? Python 2, version 2, more or less, was there. And there were a lot of packages available, but they were kind of independent. It was a fragmented environment. Also, I actually lack any local support. I remember going around the institute back in 2010 and asking, do you know Python? Nobody was aware of Python, at least at the physics department, at least at astronomy group, in order to be fair. Perhaps in another division, they knew Python, and probably the computer science department knew about Python. But the problem was that I couldn't find somebody to depend or ask. My only help would be internet and Stack Overflow, right? No AI, unfortunately, back then. So I took a leap of faith, and I said, OK, I'm going to work with Python. I think this is the future, so I'm going to start working with Python with any hurdles I may face. And I started working with PyRaff, which is a Python wrapper for IRAF, and of course, standard libraries like NumPy, Matplotlib, and Scientific Python. This is one of the very early Python scripts, date May of 2010. Okay, Python 2, you see, print without any parentheses. It may sound weird, but that's the case. And then, very close, around 2013, we had the first release of AstroPy. AstroPy is a community effort to develop a common core package for astronomy, to include actually all astronomy-related packages. It was sparked by community need and collaboration in the field. The initial idea was back in 2011, and they managed to get to the first release within 18 months, mainly because they had a lot of pre-existing packages. It has been community-based in the sense that the community, a lot of students, postdocs, scientists, and professional software developers supported this effort. And actually, the support by the Space Telescope Science Institute was critical in order to make it a success. Of course, people tried to include and foster the growth of a broad community, and they were lucky because there was a rapid growth of GitHub and other open collaboration tools that helped to put everything together. What AstroPy did, it managed to unify assess astronomy tools like fits handling, coordinates, etc., with the main Python ecosystem and include legacy packages. And this helped to create an interoperable library, allowing also affiliated packages, which means people independently developing packages that would follow the core idea of AstroPy. And there was also a series in Python, in astronomy conference series, that actually boost the use of Python. Now, where is Python used today? Sorry, before that, this is a list of the native libraries. This is just a selection, right? It's not the whole ecosystem. And some names of astro libraries which are very specific, like utilities for photometry or spectroscopy, specifically astro machine learning, more based on astronomy-related things, PyHammer, which is a package to do spectral classification. So, where is Python used today? Almost everywhere. You can find it in the space telescopes, and not on the space telescopes, but as pipelines or calibration pipelines in the ground, like Hubble, James Webb, Gaia. You can find it in the largest ground-based facilities, Subaru Telescope, ESO in Chile, also Vera C. Rubin Observatory, the one that I showed from the images, and the Square Kilometre Array Observatory. These two will become more clear in a while. There's another field where Python played a critical role. It has to do with the era of big data and AI in astronomy. As survey is becoming larger and larger, the products are increasing in size. And that challenges a lot how we capture, clean, transfer, store, analyze and visualize this data. And we'll show you some examples. Then it is velocity. How fast are these data generating? This challenging, how we do the processing of this data. And last, there is a huge variety. Various astronomical sky surveys include images. They include catalogs. They include measurements of any kind, flux, velocities. They may have also time in taking the same source observed in different epochs, and may have also simulation data. And some of them may have hundreds of features. And if you try to compare different surveys, you will see that they may have different formats. So this is kind of a challenging of how you do data integration and high-dimensional data visualization. So I'll show you now one example of Verancy Rubin Observatory and why we're talking about big data. Do you see this? This is the largest CCD produced probably up to today. It is 64 centimeters in diameter, and it's about 3.2 gigapixels and produces 8 gigabytes per image. And this image is produced every 40 seconds. What does it mean? That within a night, you produce up to 20 terabytes. Okay, what is this is equivalent of 3 years watching Netflix in a night. Probably we cannot do that, of course. So this puts a lot of challenges. Every night, there are many of these exposures obtained. And not only that, within 60 seconds, we have to do all of this processing. I will not go through the list, doesn't really matter, but there is a lot of stuff like, for example, image characterization. You have to measure something for this. You have to do some image reduction. And this takes some time, but this needs to be compressed within 60 seconds, right? And not only that, this survey wants to produce some alerts. It looks at the sky, observes continuously, and there are many phenomena that we call transit phenomena. You see them once, or some of them can be repeated, but the point is that you want to catch them at the right time. And in order to do that, you have some software systems called alert brokers. What they try to do is take let's say, the appearance of an object and transfer this information as fast as possible in order for other observatories to follow up with other observations. And in order to do that, you need to filter the alerts or cross-match with previous catalogs in order to identify if this is something new and important or not, and a number of other steps. And imagine that these alerts can be up to 10 million per night, and you have to do that for all of them. And this, of course, cannot be done elsewhere, else rather than use AI. Okay? Good. Now, let's go to another amazing example about big data, and probably it is the ultimate challenge of big data. So what do you think would be the data generation rate in this radio project? Any ideas, perhaps? Just any number? Like, I don't know, 8 gigabytes per second? Okay. 1 to 2.5 terabytes per second. Okay. This is, sorry, I don't know if this is something like 45 years of non-stop 4K movie watching per second. This is huge. I mean, this is not feasible to do that. You cannot store this amount of data, right? The only thing you can do is try in real time and near live processing to do all the necessary steps and keep the final products. And in order to do that, they're going to use two science data processors, as they call, which is about 135 petaflops, and these are considered two of the, let's say, among the fastest supercomputers existed back in 2020s. So you understand how important it is to use modern and actually develop new approaches in order to serve astronomy. Another example of big data is Gaia mission, which has resulted in 1.8 billion sources. Some of them has about more than 300 features. And you have also time series data, you have flux measurements in 3 different fields, you have spectra, and you can understand that there's a variety of features that you need to deal with. So I hope that I have actually convinced you that big data and AI is very important in astronomy. And of course, this is a challenge for modern astronomers. As astronomers or astrophysicists, we are actually trained a lot in the science of physics and the astrophysics needed. We do not get a lot of training with respect to computer skills that are needed, like coding. Python is a must now. Data handling, storage solutions, AI tools, statistics, even statistics. The curriculum perhaps have one course, but this is not enough. Astronomy is data-driven and needs this training. To address that, me, along with some other colleagues, friends, actually, we initiated back in 2019 what we call Summer School for Astrostatistics in Crete. What we try to do is to train people that they know something and manage to convert them from basic practitioners up to professional practitioners on these topics. This is just a small presentation of the core of the program, what we try to do: classical, Bayesian statistics, Markov chain, Monte Carlo simulation, machine learning, deep learning, introduction, clustering, classification, and this is the core of our program. And at the same time, we try to spice it up every year with something new, like time series analysis, convolutional neural networks, diffusion models, GPU parallelization, Gaussian processes, even applications through citizen science. This in order to try to give an overview of the field and give them tools that they can use in their everyday research. So this is, let's say the core, the backbone of our approach. This is an intensive 1-week program, but it includes beach time, guaranteed. We have a small number of people because we are using a computer lab provided by the physics department of Crete, and we cannot fit more than 30 persons, unfortunately. But we do require in-person attendance in order to have the better facilitation of the school. Then it is totally hands-on. What it means, we have the minimal theory that is needed, but a lot of exercise in order to people get acquainted with the tools. And of course, we are using Python through Jupyter Notebooks because it is interactive and easy to share. We have the last years, we have implemented Conda environments in order to avoid any unexpected troubleshooting. We just have the Conda environment installed. People call the Conda, they enter the Conda environment and they run the exercise through this. We are using real data, of course, in order to make it more attractive for people. And we actually enforce pair coding. We show that this works a lot because people get connected, they share, and they network. And of course, it is an open science project, which means that all the repo is totally public and with an open license, which means that you can get it and use it, adjust it, and apply it to your own institute. So this is a bit of the statistics. What we have, the applications we have received so far is more than 500. It's an oversubscription of 4. Unfortunately, we cannot accept all of them, but at the same time, it shows the need in the field. People, students especially, and early postdocs really need this training. We have managed to train a bit more than 150 students from 55 different institutes and 21 countries, and you can see the split around here. And also, it is very important that we get acknowledged for this work as people acknowledge us at the publications, and this is really cool. It shows that we actually have an impact in what they do. So, what's next? We saw that this, let's say, initiative worked. So we would like now to standardize. We have created this Astronaut Academy to work as a global open platform to teach statistics and AI tools with Python. Of course, the focus is in astronomy right now, but with help, we can easily expand this to other fields. For example, the code, let's say the basic core of what we do is the same, whether you do astronomy, whether you do biology, whether you do something else. An example of this is that we have the first international workshop outside Crete in this coming November, and we'll see. I mean, the future is in front of us. So these are the data, the information. If you want to come in to contact us, and then I would like to close my talk with some remarks. Right. So the first one, which is very important, very critical, is that tensors are functions. Right? This is what you need to get out of this conference. Then, Python does not bring code and nice tools only. It comes with an open, friendly, and inclusive community that allows everyone to join and contribute. This has allowed the development of so many tools and the impact in astronomy. We are very lucky in astronomy because we already have a very international and interconnection environment. Astronomy, over the last few decades, has become very dependent on the international collaboration. All these projects that I referred to previously, all the space missions, most of them are international. There are almost all countries involved. And it is also important because it also provides ideas of how you share data and knowledge. Okay? This is very, very important in the science community. And last but not least, I would like to think of Python as a way or as a tool that helps us understand the universe, right? And this is the deepest image we have observed so far. This is a James Webb image back to about 4.6 billion years, almost around the time that the solar system was forming. That's all on my side.
Thank you so much, Grigori, for sharing your story. It was very interesting, I think, for all of us to understand how Python is woven into every facet of astrophysics. We're going to follow up with a coffee break now, and in 20 minutes you're going to join us again for the rest of the sessions. Cool. Thank you.
Ναι, κάτσε. Ωραία. Σκεφτόμουν αν θα αρέσει και δηλαδή προσπάθησα να το κάνω, ξέρεις.
Okay, before we start, I'll add a note that this is a 30-minute slot, but we want to make this interactive at the end as well. So we're going to discuss some pre-prepared things for 20 minutes, and then there's going to be a 10-minute Q&A. So please ask us questions at the end so we can hear your thoughts and your feedback and hear your questions and see how we can best support you all. That's enough.
All right, welcome everyone. So in this panel, we're gonna discuss about how PyCon Greece organizers managed to organize this conference and what issues they had, what was their journey. We have Kali, Panagiotis, Vasiliki, and Dissandros. And yep, let's give them a round of applause first. All right, so if everyone has their coffee in their hand, I'm going to start with the first question. So, what motivated each of you to get involved in organizing PyCon Greece? And how did you first step into volunteering for the Python community?
I'll start. I'm going to say that the motivation was different in every step of the way. The first motivation I ever got was from attending conferences and going to many PyCons, to EuroPython, seeing how volunteer-led communities are organized and how volunteer-led conferences are being put together there. And that was the initial motivation and the initial spark, let's say. And then as the months or the years went by, it was mostly the other people that motivated me, and working with this amazing set of people that kept me going. So yeah, it was a mix of things.
Good morning, everyone. For me, it was because when I started my career, I had to find everything on my own, the hard way. I didn't have any community to interact with and to share my thoughts. So after that, when I had free time, I wanted to give back to the community and inspire others to start in tech. And I devoted my free time to communities, especially women in tech. And when I meet Lysandros and the rest of the team of PyGreece, I wanted to get involved, so that's from my side.
Okay, good morning. The starting point for me in order to contribute to all of this, as I mentioned yesterday, was the Python community. However, what it truly motivates me and motivated me in order to participate in all of this Python conference was the people. And in every meeting we had weekly, they told stories in the conference for EuroPython. And in my mind was always, no, if you want to live the same experience, you don't have to participate, you have to create your own one.
Nice. Good morning. Yeah. So for me, something similar as Panagiotis said. It really motivates me to have all these people around me. And building something like this is all about community, is all about the people that you meet and really inspire you. We have difficulties, we had our moments, but at the end of the day, this team and the community that we can build and we can create, it is something very, very strong and gives you all the power, to move on. So yeah, that's for me.
We're back. So I hope those are those are enough reasons for new people to organize new conferences. So let's move on. I want to ask a question about what was the thing that inspired you guys to bring and make the first ever PyCon Greece, and how did you guys form the organizing team? What was the process for that?
I'm going to take this. It's a really long story, and I could be talking about it for days, but in essence, I attended my first Python conference in 2017 as a first-year university student. And from the very beginning, I fell in love with the community and with everything that I saw and everything that was happening in front of me and beside me. And then I continued going to conferences, being part of the Python community. I became involved in the tech side of things by getting involved in the Python core project. And then years went by, and I was alone in all of this because I didn't know anyone else from Greece that I could work on this together. And I started something on my own in 2021, a meetup. I call it Pi Greece, and we just had one meetup, and that was it because it never became a thing. But then Fanis came along about 3 years ago now. If it's 3, it's crazy. It might be 2. Fanis came along and asked me, "Hey, I've seen you did this. Let's organize something together." And that was what basically started all of this. And I think that was the biggest learning for me in all my years in the community, that in order to succeed in something, you have to have a support network and having someone push you through the hard times. Like Fanis pushed me and I pushed him. And we sort of started forming the organizing team. Zisopoulos came along, Panagiotis then with a translation project, and then the team started forming itself. I think it all came along very organically. It wasn't like we were out recruiting people and just shouting to everyone, "You should join us." It was actually people that came to us out of the goodness of their hearts and out of the passion they had for what we were doing. So it all was very organic.
Yeah, and I assume it was really heartwarming when those people showed up.
Absolutely. I mean, nothing better than that.
Yep. So we got how it started, but what has been the biggest challenge so far, and what's something that surprised you in a good way?
I'm gonna go again. Biggest challenge so far, I mean, for me, it's certainly been the weekly being there. Be there every week, every day, through all of the stuff that needs handling, good or bad. I mean, it's just tiring. Even if it were just good, it wasn't. But even if it were, it would still be tiring. And that was a challenge, certainly. Surprised me in a good way. The fact that we never had a single disagreement between the team. It all went so smoothly, I could not believe it. When we started with Fanis, we knew we might have problems, because as the team grows, more people come in. It might be very different people from different backgrounds. And we were sort of discussing how we were going to handle tensions between team members, but it never became reality, and that was one of the best surprises ever.
I totally agree with the point Lisandros said before. And I would like to add that, from my point of view, securing sponsors was also a challenge for the first ever PyCon in Greece. And also the surprising thing that all these companies trusted us and are here today with us.
I will share my biggest challenge, and basically the most time-consuming and something unexpected was the ticket platform. We had difficulties with the ticket platform, and in order to give a pass to Kali, thanks to Kali, because if you saw her in EuroPython with a laptop, she simply added every ticket manually.
Yes, that was a problem, actually. Oof. So yeah, the challenge is not letting the challenges defeat you, actually. I mean, you have to handle everything. You have to stay calm. And that's what really surprised me, that we were calm all the way. We were trying to support each other. We had many difficulties, I can say as well a few, but yeah, I think that really surprised me. And it was amazing that everyone was there and helping, and everything went so smoothly. So yeah, I'm really proud of us.
Yeah, those are big challenges, and you guys for sure overcame those, and here we are. So I'll move on to the next question. What skills have you gained from volunteering, and what did you personally, like what was your character growth? And what might new volunteers take away from this experience?
Yeah, that's a really good question, and I will say that I'll speak for me, but I think that's true for everyone, that our characters are being formed by this experience every day. The one thing I learned a lot, and I didn't have a lot of experience. I mean, I had experience with it, but I hadn't experienced it this way. And I'm gonna say I learned this from Fanny's the most, how to be empathetic and encouraging and stuff like that. I mean, if you see Fanny's, you've seen him around, bald head, like he's right there, yeah, like very intimidating, like sort of face, but he's the most empathetic person, you know. And I think I really learned how. He just left.
Let's give a round of applause for Fanny's.
Yes, let's do it. Yeah, like getting messages on Discord from him for things like, hey, how do we encourage the team, and how do we make them take some time off and stuff like that. And it was all a big learning, and I felt like that helped me a lot.
For me, it was that it improved my communication skills and my ability to handle special cases. But I believe that for every one of us, it's something different or the same, but you definitely gain something from this experience.
Yes, it always the soft skills. Something that I learned from this experience is how easy it is to open an AMKE company in Greece, and how much difficulties we faced to open a company bank account.
Yeah. So, I'm sorry. As Lisandro said, all of us has totally changed during this process. For me, this thing totally boosted my confidence and changed me and helped me handle the imposter syndrome. I learned a lot, and I think that the volunteers will have these skills and will gain these skills as well. it is very important to be part of it and to have all those new skills and to learn how to organize something. We have a lot of difficulties, as we said, but why not do it? Why not help something somehow? I don't know. So yeah, confidence and imposter syndrome.
Well, as all of these amazing people told, skills always doesn't have to be technical. Like, these skills are really important. So I'll move on to the next question, and it is about the most heartwarming moment so far in this journey.
You have a funny story to share. You want to share it?
So, a funny story begins when we planned with a team to make a meeting with our booth vendor. That period, I didn't have a car, so I had to use a commute train, Prastiakos, and use my feet to walk, about 2 kilometers from the station. As I walking, I met agricultural crops, goats, and I crossed a river, not the Kifissos, I crossed a river in Kadza, somehow, I don't know.
Heartwarming stories. I think I think one of the most heartwarming moments for me was yesterday when Panagiotis was giving his talk. I was crying like a baby from being too emotional about it. So I'll go with that.
For me, my most heartwarming moment was Lais's keynote. It was amazing. Lais, if you're here, we love you.
For me, I knew it from the beginning. The whole team, the whole day, the whole, those 2 days, I'm sorry, I'm getting so emotional. I knew it from the beginning that it would be very exciting. I'm very happy to be part of it, and I feel very overwhelmed sometimes, but yeah, I don't know, that's it. Everyone, this place, this conference, yeah, PyCon.
Yeah, it really warms our heart to see our amazing audience in these halls, so I'll want another round of applause for this amazing audience. So, the next question is about the future. How do you see the Python community in Greece evolves after this event?
I think the goal for all of us from the very beginning was to inspire people, to bring our experiences and the things we've seen in conferences around the world to Greece and to showcase everything to the Greek community, and hopefully the Greek community now will I mean, it already is thriving, but it'll thrive even more, and we really hope the Greek community can take this and form it into something like really special, like we have envisioned it. A lot of the people in the organizing team actually do not live in Greece, and that's why we'd like to see more people come in. Give us their own backgrounds, their own experiences, and sort of we can then work all together with our experiences and theirs to form something really special, like what this first PyCon has become.
I totally agree. Do you want to add something?
Okay, we're back. Yeah, so I think PyCon Greece is a really good example, a really great example of how a country, of a community can organize a conference from scratch and find sponsors, find the audience, find venues. Like, this is a great example. And if you want to organize something in your country, I think you should talk to these great people. And before we move on to the questions from you, I want to add that if you're organizing a conference, there are grants programs. Could be from PSF, could be from EPS, Python Software Foundation, and EuroPython Society. We have our grants programs. So apply, and we're going to move on to the questions from the audience. So, who has questions? For the time's sake, if you have any questions in mind, please come to the front so we can give the mic easily.
Thank you. Hi all. Thank you for organizing all this. If my opinion matters, I have been in organizing teams in many big events. I have organized 3 TEDx events, and last year we organized in Larissa the first WordCamp that wasn't in Athens. And I can see that you have done a very good job here, and you should be proud of yourself. So my question is, let's say that you do another PyCon next year. What would you change? And what tools would you need, or even to develop yourself in order to make your life easier and to make all this organization more automated? Thank you.
What would we change? That's a really good question. I think up until now we've just been way too focused on this first one, and it's going to be a couple of months before we start thinking about the next one. One thing we certainly are thinking about is how much hype there was around the event. We ended up getting sold out and having 250 people in the waiting list. So that's something to consider for next year, see whether we can make the event bigger. But in order to do that, we'll need more people to join us, because it cannot be possible by any means to organize a 500 people event with just the people that are here. What tools do we need? We've been somewhat scrappy, but at the same time, we've been using a lot of stuff to help us out. There's certainly stuff that can be automated for next year, but up until now, it was just run with a single target, getting there. So there wasn't too much time thinking about tools. That's going to be another discussion in about like a month or two. What? New ticketing platform. Not sure if we're allowed to say that.
Okay, we have a question.
So have you organized any event before this conference, or this is your first event organization experience?
Yes. It's my first time being an organizer. I've been a volunteer before.
Very nice starting.
Actually, all of us, yes.
Thank you for organizing such a great event.
Thank you. Thank you for being here.
Hey, can you come a bit? Yeah. If you have any questions in your mind, please come towards the front.
Thank you. First of all, I would like to say that it's a really nice event. Thank you for organizing. And I felt more lonely in the Python in my Python involvement before this. And I think that's a really big achievement from your side. My question is, how did you find out about PyCons in the first place? Because for me, it's the first time attending one, and I would like to know your experiences. Thank you.
I will pass you the microphone because you have more experience PyCon.
The first PyCon I attended was the next block from my apartment at the time, so I guess that was the way I found out about it. It was in Berlin, in like a hospital, or like a hospital campus. So I think that was the way I found out about it. And yeah, and then the rest happened kind of by themselves, because I found out about the first one, I loved it, and then I started searching about it. Do you mean?
This is my first PyCon ever, so I learned about these events from the rest of the PyGreece team.
Me too, the same as Vasiliki.
I have the same answer as well. And I was part of EuroPython, so yeah, I learned some stuff from there, and we brought this knowledge here.
So I'll also say it's a really impressive effort, and congratulations on everything you've done. I have lots of questions. The first one is, one of the things I like about the conference is that while it's addressed mostly to the Greek community here, you've not excluded people from abroad, in theory or in practice. So how easy was it to make sure you have international attendance, both speakers and in the audience?
For us, the main goal is to make this conference as accessible as possible. That's why all the talks are in English. Also, we had the Keynote program, me, Vasiliki, and Cleopatra, which helps attendees across the world. The budget was limited, and this was a challenge, but I think we made it. We managed to bring people from, I think, from Europe, from Africa, from Asia, speakers, but also attendees.
I want to ask, all the team is Greek and you speak in your native language, you read the organization code. Do you ever face like a language barrier? Or like, first question, do you ever thought about, a Greek track to maybe, I don't know, the Greek population, how they know English very well, like stuff like this?
There wasn't a language barrier among the organizing team. We're all Greek, so we all spoke Greek to one another. We thought about doing the whole conference in Greek as well. As Panagiotis said, the decision was to make it as inclusive as possible by it being in English. And yeah, there was thoughts about a Greek track, but doing a 2 parallel tracks conference was already a challenge for us, so doing a third one in Greek was not possible in the first edition. It will surely be a discussion for the next editions. Sure.
Hi from me as well. I would like to ask, how was the process of getting the brand name available in Greece? Like PyCon, could you just use it, or was there a process behind it that was?
That was the biggest challenge. There is a short story that is not needed to tell it here. 1 year ago, in order to get the PyCon trademark, you need to apply at PSF, Python Software Foundation, in order to get it. Long story short, not only PyGreece wanted the trademark, also another entity wanted, but okay, it's this story. we had challenges about 3-4 months that delayed us in the whole process, but we made it. Someone, are you okay? Okay, okay. So, yes, what I said, yes, this process delayed us for between 3 and 4 months, but it's there. We take it. We win.
Amazing. So we don't have time for more questions, so I'm going to ask the last question, and we're going to wrap it up. So for someone in the audience who wants to help but isn't sure how, what's the first step they should take after today?
Come talk to us, not after today, but today. And if not today, then send us a message tomorrow or next week. And I hope you can see we're like a group of friendly people, and we really need your help. And yeah, come find us, talk to us, and ask how you can help, and we'll help you as well.
And if you don't find us in person, please join our Discord server. You will find us there, definitely.
All right, thanks all for joining. Let's give a round of applause. And we're gonna have the next talk by Efe, I think, in 3 minutes. So go get refreshed and come back.
Yo. Hi, everybody. Awesome. Wow. It's very nice to see actually familiar faces from yesterday. So let's move on to it very fast. For the next one, we have a very nice talk by Jefe. He's currently living in the Netherlands, and he's a very good software engineer. We're going to delve into the multilingual Django applications with a sprinkle of AI. So do me a favor and bring your hands together for Jefe.
Thank you very much, everyone. After the panel, it's also very emotional for me because I saw how much effort you put on this good conference. I also attended a couple of professional events, and most of the time people were just checking their clock, what time they're going to leave from the conference. But in here, I can see this sparkle in people's eyes. It's so nice. I just would like to ask for another round of applause for the organizers, please. So today I'm going to talk about something a bit related to also Greek. It's about multilingual Django applications. Before starting, I also would like to make a small exercise with our arms. Can you raise your arms if you are developed a project before Django with before? Half of the crowd, nice. So have you developed multilingual applications with Django before, maybe? Nice. So this is a perfect talk for you because there is a content for you. You're gonna at least have something in your mind after the talk. So let me introduce myself. I'm Efe. I'm originally from Turkey, but I live in Netherlands. I worked in a couple of early phase startups as a founding engineer. Right now I'm working at SendCloud as a senior engineer. I have a blog at efe.me. And I also try to be active in the community, give back to the community. I'm a mentor in Django Girls Amsterdam, and I try to also participate to Django NL. I like Django mostly, and the talk is also related to Django. I like Python, I like recent LLMs, and I'm mostly backend person. And I also like boring technology. If you don't know this term, please check after the presentation. You're gonna find it interesting, in my opinion. So this is me. I like playing backgammon. This is me and my co-founder. We got investment. No, just kidding. I like running. Okay, what is the agenda from today? So the first, we're going to touch about what is the multilingual application, more like textbook definition. Then we're going to touch how we can understand the language of user. Then we're going to deep dive to the Django side. We're going to talk about how we can do this type of Django web framework. In the fourth step, we're going to talk about how we can automate this type of things with AI. And then I think this is also something can learn, something interesting for experts in Django, I guess. So what is multilingual application? Multilingual application is an app which serves more than one language. You can think about texts on buttons or emails, everything. So if application serves more than one language, it's a multilingual application. And it's not only about the language itself, it's also about how we show the data. For example, in the second item, you're gonna see that the data representation is actually different in European Union and in United States. For example, 13th of December looks like this. In European Union, we put a day in front of the date notation, but in US, it's the opposite. And in the multilingual application, users also can change the language. This is also a must for us. Also, in the fourth step, as you can see, we should have support for different writing styles. In English, it's from left to right, but in Arabic, it should be right to left. But today, we're gonna touch only the first and third items, how we're gonna have translatable backend applications. So, most of the time, we write the application in one language, and the best practice is doing it in English, because when we are defining our variables, we should also follow the same language with the text. So as a best practice, I usually suggest English for this, even though your application is also going to be mostly used in Greek, for example. And we should differentiate the strings. Are they going to be user-facing strings or mostly for backend purposes? So if they are user-facing strings, we should define them translatable. But if they are not, we don't need to deal with the translations, because translations actually brings cost for us. So okay, now we know a bit of what is multilingual application. Now we can move to how we can understand the user language. This is actually one of the common questions in coding interviews. They usually ask you, okay, if I go to pycongreece.com, what's going to happen on the background? Most people talk about, okay, there's the DNS, we're going to look up the DNS, where is the IP address, we're going to do this type of things. But actually, I would like to touch something about more high level, which is a HTTP protocol. It is called content negotiation. But negotiation of what? I summarized them in 4 items. The first one is media type. For example, you can have an application, a mobile application, which only works with JSON responses. So therefore, you should send in the request header as an application JSON. So therefore, your browser, your mobile application should say, when they are making a request, what type of things it is eligible to render. And the second thing is character encoding. So we have different character encodings, and most common one is UTF-8, and all browsers also send this information as accept charset. And in the third one, this is related to our talk, which is accept language. So as you know, in the operating system, we define which languages which we can use in keyboards, in other stuff. So therefore, our operating system gets this information, gives to the browser. Then browser puts this information to every HTTP request. So therefore, websites can understand which languages can we interpret. And the fourth one is about accept encoding. For example, if you like to compress your website with gzip and reduce the transfer times, you can also use different accept encodings, but not all of them are supported by every browser. For example, broadly wasn't supported by Safari for a long time, so therefore, the server is not going to send broadly compressed files. Okay, we know that accept language is a standard, but we shouldn't fully depend on this. Because why? Imagine that you are using someone else's computer, and this might be in Chinese, in Turkish, a language you don't know. So therefore, you need to have a way to change language in any application. But this is a good practice to have accept language is a default language. And as I mentioned, it's nice practice to have this drop-down for anonymous users or authenticated users to toggle their language. And if they are unauthenticated, it's a bit hard to keep it in database. So therefore, it's also good practice to keep it in the session. And if they are already authenticated, you can keep it in the user model. And I also check a bit what type of weird or unorthodox multilingual applications. And I found this website, which is called Transfermarkt. Is there anyone who is into football? Yes, I think you know that. And this website is a bit weird way to have a multilingual applications. I think they were super rich. They got all the domains with the Transfermarkt, and they are doing routing by checking their TLD codes. Like, for example, for Greek language, they have GR. So if you go transfermarkt.gr, it renders in Greek. But this is an expensive method. I don't suggest this. Okay, what is our checklist for detecting the user's language? If the user is unauthenticated, have default for accept language. Then if they toggle the language, keep it in the session, rely on session. And if they are authenticated, please get the information from user.language. Okay, it was mostly HTTP protocol principles. It can be applied for any backend application if you write with Ruby or any PHP framework. So let's talk about Python and Django. So this is a simple code snippet from Django views. And Django, under the hood, uses a library called getText. GetText is actually created for Linux or maybe in GNU world, which is used for almost all open source or free softwares. And Django, instead of creating a new standard, they just use this existing software, but they just wrote a wrapper for this getText. And you can see there is a request in the my view, and it just returns an output, which is welcome to my site. And also, yesterday, Jan made a talk about import. And this is also one of the examples for this. There is a common way to use getText alias, because we're going to use getText in most of the strings. So therefore, instead of importing all the time with getText, we import it as underscore, and we call it underscore whenever we use. But there is a trick in here. We also had a couple of talks about T-strings, but I would like to talk about F-strings. So in F-strings, you can pass, you can get the name and pass the F-string directly like this. But F-strings actually calculated or evaluated before the getText. So therefore, we are not going to have the context in here. So therefore, please don't use F-strings when you have a multilingual application. Also, you can make translator's life easier. And if you have a bit generic text, you can always put a comment, and you can have a translator's prefix, and this context is going to send to the translator. And of course, we also have plurals. And when we have plurals, sometimes we might change a behavior of text. For example, in here, there is one object, or there are 3 objects. So therefore, we cannot use getText for this, and there is a specific method for it, which is called nGetText. So up to now, it's more about views, sending emails, this type of things about request-response cycle. But when we run a Django application, we also pass from some codes. For example, model definitions. And when Django application iterates over the model definitions, actually, there is no user in the context. So therefore, we should use a lazy getText in here. Whenever this method is called, Django is going to call the function inside of the view or related code. Okay, we covered how we can declare a translatable text in our Django applications. The second step is we need to define our settings, what type of languages we would like to support. And as I said before, we should most probably have English as a default language. Then we can define the other languages in here. And I defined Greek in here as a second language. Then we need to set the local middleware after the session middleware in our settings. It comes with default. Django has good default, so when you boot up a new project, it's the correct order. But if you change the orders, please be careful about it, because otherwise you might have a weird translated responses. Then, as you know, we defined this translatable text, we defined our languages. Now it's time to create our text. What type of text we are going to translate. And for this, we're going to run a Django management command, which is Python managed by make migrations. You can also pass languages to this management command, but I just wanted to list all versions. And you're going to see this example file. Let's check this together. Basically, it has two files, two pairs for everything, which is message ID and message string. Message ID is the ID of string which we are going to translate, and message string is equivalent of it in the target language. And as you can see, this is a file for Greek languages. If we have multiple languages in our application, we're going to have, for example, a Turkish file for this. Then you need to find the translator. I think this is the most time-consuming part. You need to upload file, they're going to translate, you're going to download it, and most of the time you have out-of-sync translations because of it. I think this is the most time-consuming part. It is not a technical problem, it's more like a business problem, but I have something for you. But I'm going to explain later. Let's complete our flow first. So then we find the translator, if translator fill these empty strings, then we need to compile these messages to more files, because PO files is not readable for Django application. And this is our basically a flow. This is our checklist. We defined our get texts, which text should be translated. We defined the languages. We use middleware. Then we started the translation process. We said we're going to use make migrations. We find the translator. We compile the messages. Yes. Now we speak Greek. We speak Greek. But as I said, having a translator is an expensive thing. And with recent LLMs, I would like to optimize this. So this is a package which I implemented. It is called YesCloud. It is a simple Django app which you can use in your applications. You can check the QR code. What it does, it actually introduces a new management command to your Django application. And you can just call manage by translate messages. And it is going to iterate over all of your languages and get the empty strings sent to the LLM and write the responses back to the files. And it is going to also batch the untranslated strings, so therefore you are going to also pay less for any LLM provider. And this is the result of it for Greek language. To be honest, I cannot speak Greek. Maybe you can decide is it a good thing or bad thing. Yeah. But how we can install it in our application? Basically, you can just say pip install YesCloud. Then you just need to add YesCloud to your installed applications. Then it works with LLMs. You can use any LLMs. It can be from cloud, it can be from Google, it can be from OpenAI. It uses light LLM under the hood, and it supports more than 100 LLMs. So this is the new checklist I suggest. Instead of finding a translator, I just ask you to stay in your terminal, just run translate messages management command, and everything is going to work smooth as butter, I hope. So it works with more than 100 LLMs. It keeps the placeholders, just one management command. It also prints out the cost of your translations. And it also batches, so therefore you're going to pay less and it's going to take less time. It is, of course, free to use, also free to contribute. You can see open issues in the package. If you would like to contribute to open source, you can take any issue from here. If you'd like to talk with me, we can talk about it and add these features together. And at demo, this is the end for my talk. If you have any questions, I'm happy to answer them.
Thank you very much, Efe. This was a very nice one. So people, anybody? Anyone?
Thank you. First of all, thank you for the presentation. So my question is, sometimes when you translate something from English, for example, to Greek, the translation can be accurate, but it doesn't sound very natural. how do you address this challenge where you can translate something but it doesn't seem natural to a native speaker? Thank you.
Thank you very much for the question. So in Yes Cloud package, actually, it is possible to customize the prompt. So if you would like to set a tone of translation, you can edit in the settings with the custom prompt. You can say that make it more funny, make it more business related. Also, you can add business related keywords to this. So therefore, I guess LLMs can learn from these suggestions and bring more quality translations. But I also say that translation is like a weather that you can always find someone who can complain about it. So it's so subjective. I try to find scientific methods to measure the quality of translation, but to be honest, it's so hard to do.
That's actually a very good point. I totally agree with you on this one. Another one? Come on, people. No? Alrighty. Okay. Then, thank you very much, Efe. We don't have any question. You can always...
Thank you.
Thank you. You can always find Efe around, ask them questions, I suppose. So we have our next talk at 12:30. So bear with us and see you in a bit. So, welcome back, everybody. For the next one, I'm very, very pleased to introduce to you Anushka. She actually comes from India and is a software engineer for Adobe. So this is going to be a very insightful one. The topic of the talk is going to be the AI accessibility and how to keep your users actually from rage quitting. So please give it up for Anushka.
So hello everyone and welcome to this session. Before I start on accessibility and everything that I have on my deck, I want a quick raise of hands. Has anyone ever used just a keyboard to navigate through a website by pressing tab? Okay, interesting. Has anyone ever used a voice recorder, screen reader to read through the screen? Okay, interesting. So the examples that I'm going to give today are mostly for people who use screen readers or keyboards or any sort of assistive tech to go through their, or to navigate to any through website. So yeah, I mean, although we saw that the number of hands in both the scenarios were not a lot, but yeah, there are a lot of people out there who utilize it. And now these days with growing tech, we have generated images, generated video captions, generated layouts, and even generated websites. So imagine how is it going to be for people who use these assistive techs to navigate through website when AI comes in there. Because although AI is doing great things, but yeah, I mean, there are a lot of loopholes there. So if I had to give an example, I was once reading an article, and in that, AI auto-captioned image of a microwave, calling it as an innovative mailbox. Now, for someone who can look at that image and see the text visibly, they can make sense that, okay, AI probably has gone wrong, and it isn't really an innovative mailbox, but something that you would use for your food or something that you would use for heating up. But imagine, what if someone was just looking at, or was just hearing that, okay, there's some image of innovative mailbox, and then there's a lot of content around heating food. So that will be so confusing. So yes, now let's move on to the topic and talk a bit about what accessibility means, what websites, what are the checkpoints that a website should have, and yeah, I mean, if you're using AI-generated content on your websites, what all you can do to make them accessible for everyone. So before starting off, I want to go on a quick introduction about myself. So I am Anushka Narula. I come from India. I work at Adobe as a software engineer, and I work on a product called Adobe Express. So Adobe Express is a product which is a beginner-friendly one where users can bring out their creative imaginations in the form of posters, flyers, or any creative content. And yeah, even this presentation is made on Adobe Express. Apart from that, I'm pursuing masters from Georgia Tech. So yeah, that gives me, the technical knowledge of machine learning and AI, and I kind of utilize some of it in my product work at Adobe. So yeah, that's about me. And when I get time from each of these, I travel around, go to community events, go to conferences, and even speak at some. So that's about me. So starting on what makes a web page truly accessible. So there are 4 principles, and it's actually called the POUR, P-O-U-R. So P stands for perceivable, which means that they should be able to, that users should be able to perceive all the content. It means that, there should be at least, if you have some creatives on your website, people should be able to, understand in some way, like there should be alternate texts to it so that screen readers read them out. Or there should be captions for videos so that, again, screen readers read out, what's going on in the video. And color contrast also comes in here because color blindness, although, not a lot of people know about it, but it's out there in different forms. So even color contrast is a thing which comes under this, perceivable point that, okay, everything on your site should be of a proper color contrast. And there are tools to check whether, you have a proper ratio of color to text on your website or not. So that's the first thing. Second is operable. That means that anyone who's using your website should be able to operate each and every feature of it. Now, for someone who is using a mouse, looking at text, it's easier for them to, hover the mouse, click on any button, do any operation. But operable, even for the ones who are using assistive tech, which means that all the key elements, or at least all the clickable buttons on the website should be, should be reachable by the tab key or some key on the keyboard. And even if that's an AI-generated layout, make sure that this happens because a lot of times AI misses out on, making, at least adding like a focus on where the mouse is because without a focus indicator, it's going to get very, very tough. So that's about operability. The third principle is about, things should be understandable. So understandable means that content or, the language used in your website should be simple. So that, just by listening to the explanation, people can understand that, okay, what's actually happening in that image or what's actually happening in that website. And understandable even includes that, a lot of times there can be error scenarios on your websites. So like a lot of times if I say that, let's say there's an AI-generated sign-in, sign-up form. So a lot of times AI, since it has to do things very quickly, what it does is it might not clearly show the error messages to users, but it might just show that, okay, error 5xx, which is okay for a developer to understand, but think from a user point of view, especially who is, who cannot really see what's there on the screen, but they would actually, wait for the screen readers to say that, okay, what is the error and how do they correct it? So like this example which I gave that, okay, let's say there's a sign-in, sign-up form and the window says error 5xx. So a screen reader would technically read that. So how would you make such scenario better understandable is that you clearly mention that, okay, probably the password does not match the, format in which it should be or something around that. So understandable point covers that, okay, keep your language simple, convey everything out very, very clearly to your users. Then the fourth point is robustness. So that means that, everything that you build should be accessible across different devices and should be built in a way that, it can be extended beyond and, to future use cases and so on. So robustness is more of a generic point of view, like not just accessibility point, but yeah, this covers a bit of, how your semantic in UI is. So like have a proper header, have a proper body of your website, and then footer and those kind of divisions. So yeah, that's about the poor principle. Now, moving on to the next slide, I've deliberately put this image here. How many of you can clearly see all the colors and all the texts? Colors, I think you still be able to see it, but text, I feel in a lot of cases, it might get a bit tricky. Is it? Yes, no? Okay. Phew. Okay, so that's because I wanted to show that, okay, how can, if the color contrast isn't good, it can actually be disastrous. Because see, white on a lot of colors is not clearly visible. Okay, cool. So I'll be your assistive tech tool here, and I'm going to tell you about each of these. So this is more of a summary of what we saw in the principles before. So starting from the 12 o'clock, the mustard shaded segment, which says use of colors. So yeah, have a good use of colors on your website. Then moving on to the, moving on in a clockwise direction. So next is use of fonts. Use of simple fonts it's okay that, your brand image might have to use some funky fonts, but make sure that, the use of fonts and the colors together looks good and can be easily understandable by everyone. Next is website navigation. So as I said that, users should be able to navigate on your website by just using keyboard or some sort of assistive tech. Next point is content structure and semantics. So yeah, this is probably, this is what we talked about in the robustness point, that, okay, have a proper UI semantic structure so that, the other things like alt text and ARIA labels can be easily added on your UI structure easily. The next one, which is orange in color, so screen reader compatibility, which is like that, okay, screen readers should be easily able to read through all the content that you have. And yeah, it correctly conveys. So even screen readers basically read out the alt text of images or, captions of videos, or if it's a description or, straightforward text on your website, it would straight away read that. The next one in the purple color, that is images in media. So yes, it's okay to add generated images or generated media on your websites, but yeah, make sure that they have proper alternate text, alt text, or proper tags added to it. Because a lot of times, like even I generate a lot of images from a lot of AI tools, and what I have seen is they either have some alt text, but that does not always convey out what the image is doing. And a lot of times it does not have, it has an empty alt text. So that becomes a bit difficult if you straight up used those generated content on your website. Next point is keyboard accessibility. So it's not just about, the tab key on the keyboard, which you use to tab through all the elements of your website. But yeah, even, the up and down key and even other keys. So when you're building some website and, especially using AI in it, make sure to double check, think of you as if you are someone who's just going to use keyboard and no other key to, do all the functions that you would want to do from your website. And make sure that, everything works. So yeah, that's about all the things that you should be taking care of. And a kind of summary of what we discussed in the POUR principles. Moving on to the next slide, which is about accessibility challenges in AI-driven content. So as I said, that AI at times messes up some certain things, and there have been examples, like if you see on the right side of the screen, there are actually some real-life examples where, directly using things, or not even AI at times, it's not just AI, it can be regular website work as well. So, but yeah, there have been a lot of examples. So first one, as I've said, that, okay, bad or missing alt text. Like, alt text might not always convey the thing out correctly. So, try to have a good alt text. I'm going to show you a demo of, 2 models which can be used to generate alt text, and just a comparison between them. And next is about the color contrast issues. So, color contrast can go wrong if you look at this example, which is about, this was a map which was generated by AI, which was actually a replication of some ground area, and it did a lot of people, since that generated image did not have a proper color contrast, it did not clearly convey out, what the people should be looking. And since it was a news article, it did create a lot of confusion amongst people. So color contrast can go wrong at times and create a lot of misinformation among people. Next is a lack of focus control. So focus control, as I said, focus control is not just that, okay, you can tab through all the clickable elements of your website, but it even includes that, okay, wherever your keyboard pointer is, there should be a focus ring so that users know where they actually are. And there's no harm, obviously it's going to be some X icon on the page, or maybe if it's a button, it's always good to add some text, or even if it's just an icon, it's good to add some alt text to it. The fourth one is unpredictable DOM updates. Now, this is something which is very common on a lot of websites that uses AI. So imagine a website which has been showing you recommendations that okay, you're browsing for something, and then let's say you're checking out for flights from location A to B, and a lot of times a recommendation comes up on the top that, okay, here's a new offer that is coming on your flight tickets or something like that. So a lot of times, just because of these AI recommendations pop up on the top of your screen, they can actually cause a blocking experience for the ones using assistive tech, because now your focus controller or your focus indicator is just gone, and it does become difficult. So like showing recommendations is one such example, but yeah, DOM updates are very common when you have AI recommendations or things like AI-based sorting present on your website. So even that is an area where you need to look at multiple times, or be careful about whenever you have AI integrated or AI suggestions integrated on your website. And then comes bias data. So this, I think, is ever-evolving issue, because a lot of voice assistants, when you ask them questions, they return answers which are very generic, and they might not always cover information which is around people using assistive tech. So it's not, bias data is not always taken as a challenge, but yeah, at times, it's not really a UI accessibility challenge, but yeah, it's an in general accessibility challenge which happens in a lot of speech models integrated on your websites. Like this example, if you see, so speech recognition did go wrong with a lot of accents and a lot of scenarios. So yeah, that is also one thing that we need to take care of. So moving on to the tools which you can use. So one of them is Axe tool. So it's like it's a Chrome plugin that you can add on, a Chrome extension that you can add it on your Chrome browser, and then you can just run it. Is the font visible? Are you able to see it? Or I can maximize it if you want. But, okay, I don't see anything here, so I guess it's okay. So the thing is that you can open your website, open the Axe dev tool from your Chrome browser, and that is going to list out all the issues. It would actually scan your entire website, and then irrespective of whether you have AI-generated content or any sort of content on your website, it will actually list out all the errors that you have. So like in this example, it gave that, okay, elements must meet minimum color contrast ratio thresholds. So that happens twice. I guess it's with this region, gray and blue. But yeah, it acts as one tool that can help you scan things out and list issues right from your browser. The next one is Pillow library, which you can use now that we have talked about the color contrast issues. So yeah, Pillow is a Python library where you can just set the color contrast. Like here, I have an image. So initially it said that the color contrast was 3.18, which didn't actually fall into the standards defined by WCAG. But yeah, once it improved, so this is actually for, color contrast depends a lot on what text and the color of the text and the color of your image. So the contrast of the image might not look good, but the calculation is done in terms of what color of text will be added on top of it. So yeah, Pillow is one library that you can use very easily to adjust or set color, any sort of particular color contrast on your images. The next one is alt text, which again is a really important thing when it comes to AI generated content. So yeah, I mean, this example actually has the transformers library using the Vision Transformer GPT-2 model. So with this model, like I had this image and it generated a dog playing with a ball in the grass. So yeah, I mean, this is a good one. Instead, this might give some context to someone looking at that image instead of just a blank thing. There is another model which can be used here. I guess it's on the next slide. So the benefit of that, I mean, it's onto your product and onto your website that, what amount, like, whether it, see, even this alt text works great and describes the image well. But if I go to the other model, so here it is using this blip model, which is, I guess, an open source model by Salesforce. So even that can be used for, generating alt text. So I've used the same image here. And if you just look a bit, it might take a few seconds, but. So yeah, even this would generate an alt text. So now the thing, this generated a bit more descriptive alt text, which says that, okay, a small dog running through the field with the red ball in its mouth. So now, although Blip is out in the market and is considered better model, but yeah, it's on to you that, okay, to what extent is it okay for your audience to know? And yeah, I mean, these examples just had, okay, generating alt text for single examples, but in the real life scenario, this is not the case. You won't be generating alt text for individual images on your website. What I mean to convey here is that, okay, you can actually integrate these things on, while you're building websites or while you're building models which would generate websites, that, okay, make sure to generate alt text, add it to the image, and then get going. So this is the, gist of what I had through alt text. Moving on to the keyboard testing part. So Playwright is actually an end-to-end testing rule. Even, you can use that in Python. So like in this example, the demo is really fast. So like what I did was I was actually saying that, okay, tab through 15 keys. And what it did, and I gave the website URL right above. Will I be able to pause this? Okay, anyways. So the output it printed was that, okay, after the first tab, this happened. Then if you see from here, after the 5th tab, there was a focused element. And this was the element, which was actually the news tab. And so on. So you can change the number of tabs in the code and, just keep telling that, okay, test it out. And Playwright is just going to print out all the possible, not all the possible, but it would actually be tabbing through your website based on what you have, conditions that you have set above. And from here, you can actually see whether, okay, whether your elements are being focused or not, whether, they are properly being, or are they properly conveying things to, what the users would want. So although, I mean, I don't have any more tools or examples, but the thing is that these are the really common, apart from these, the best way is that, okay, human runs into the loop, you go and do the round of testing and just validate whether it works or not. And yeah, these tools are just to automate your process and, make it faster. So now talking about, kind of summarizing and, listing out the things to take care of. So yeah, label all the buttons. You might have some clickable buttons or some icons. Label all of them so that, website is clearly conveyed. Avoid using ARIA a lot of times. Like ARIA is for adding labels to a lot of your UI elements like menus, dialogues, so on. But yeah, don't overuse it or, and ARIA is even used to add roles. Like a lot of scenarios can be like div, you call role equals button and it would behave like a button. Instead of that, use HTML button tag. Then the third one is show indicator for keyboard focus. So yeah, if you don't have a proper indicator, users won't be able to see, which element is focused. Next is add skip links. So, give buttons to skip to the bottom or skip to the important content, because the ones who use assistive tech, they might not always want to, scroll through each and every element. So give this skip link button for sure. Then, yeah, make errors understandable. clearly convey what the issue is so that they know clearly what they have to do to fix it. And then, yeah, use proper UI semantics and have a proper structure of your website. Lastly, don't blindly trust AI outputs. I mean, yeah, they are fancy, they are good. They save a lot of your time when you're developing things, but they can go wrong with people using assistive tech. Then test early and often, although you have tools to automate testing, but do it yourself while you are in the process of development. Third is prioritize usability over fancy features. As I said that, Gen AI, the way it's evolving these days, you have so many good things that it can do. But yeah, accessibility is something that as developers you should take care of if you care a lot about your users. And yeah, automate accessibility testing with Python tools, because as a developer, you cannot be really doing everything. So try to add those accessibility checks, or maybe integrate the libraries that we talked about so that they can give you error alerts or error warnings that, okay, this isn't wrong or this isn't going the right way. So yeah, lastly, I'll just say that smart apps are cool, but inclusive apps are cooler. So let's build both. Thank you.
That was a very good one. We really appreciate you, Anushka. We're going to be moving on to a brief Q&A session. Please pose your questions now. Come on, people. Questions? I'm sure you have one. It's not your robot. Don't miss it. Yes. I'm coming.
Thank you for the talk. WCAG guidelines say that alt text has to be both accurate and appropriate. So you can't just describe the text. It has to be like, you have to have the context of why you have the image there. So like with the puppy, it might describe what's in the picture, but it's missing the context. Do you have any advice of how to address that?
Okay. So if I understand your question correctly, so it's majorly around that, okay, what alt text actually does. Okay, so it's like when, imagine someone who is just using a screen reader.
Oh, sorry, it's not about why to use alt text, but so you could just describe to say that there's a puppy in the picture, but like maybe you have a picture of a man holding a puppy.
Yeah, fine.
And it says a man holding a puppy, but maybe you have it there because it's actually a vet holding the puppy or something.
Yeah, exactly. So alt text actually comes into picture when, the text is not written and it's just the image. So in that case, if you are using a screen reader, so alt text is majorly, the use case is that, okay, there's no text written around the image which describes it. So that's the only use case of alt text for images, that, okay, the screen readers can read it. The alt text goes in the semantics, UI semantics, or HTML, or the HTML code of that particular image. So you're right that, okay, we can probably add a text below the image explaining what it does, or add some text around it. But yeah, the point of alt text is that, okay, it's like a hidden layer of UI which screen readers pick, as a description of what it's doing. So that is the thing. Does that answer what you were asking? Okay, good.
Cool, awesome. We have plenty of time for another one. Let's go. Come on, people, don't hold back. No? Alrighty, okay. Thank you very much again, Anushka. It was very nice. We're gonna have a lunch break right now. Please be informed before you go. 1 second, please. One announcement. The lunch is gonna be served in the in the sponsor area, and also the PyLadies lunch is gonna be happening right now in the Innov Athens Hall, which is a space for women and non-binary people of the Python community to come together, connect with each other, and build a meaningful relationship. Thank you very much, and see you in a bit.
Can you hear me now? Perfect. Hi, everyone. Welcome back. So I hope you enjoyed your lunch break. I know I certainly did. So next up, we have Cristian Maureia Ferdes, if I said it correctly. I hope so. Perfect. So Cristian is a very valued member of the Python community. And I also found out very recently he's an astrophysicist as well. So I'm very glad to introduce him today. And he's going to talk to us about the art of extending Python with other languages. Take it away. And also, a big round of applause first, then take it away.
Of course, you need to turn it on. Hello, everyone. I hope you had a nice lunch. This will be a tough audience, so I will try to sometimes raise my voice, and you will be like, what is going on around? And no, everything should be okay. Even though this is a talk about some internals, we will see some code in other languages. Don't be scared. And I promise you, just enjoy the ride, and maybe after this talk, you will learn new things. That at least is my goal. As they said, my name is Cristian. If you want to find me in social media, you can send me a message after this complaining why my talk was so bad or anything. You can just send me a message. So, languages. We are all here for Python, right? So, I am originally from Chile. There we speak Spanish. Many of you might be familiar with Spanish, of course. I live in Germany for many years now. I tried to speak German there. We are here in Greece. But the talk is in English. So languages, it's something that is very intrinsic to all the stories, right? And not only speaking one, but also programming ones. One important thing that I noticed, I really like this illustration, is that I was trying to see, do we have any close kind of like relationship between Spanish and Greek? Well, if you want to see with the languages that I was talking there, and they're very separate. So I thought, okay, well, it makes sense, different alphabet and different things, but there is a lot of influences. So I searched around, I'm an old person, so I didn't use any AI, I just searched on DuckDuckGo, and I was looking at a few words. Maybe you would say, no, that's wrong, that's not a Greek word or whatever, but I was trying to find that it's interesting that we have so many words that are super similar to you. So if I say drama, idea, filosofia, you will say, yeah, I know what you mean, right? So it's interesting how languages, even if they are not based on the same common language, they influence each other. And at the same time, languages evolve. Don't get excited, we are not starting yet. Let's watch. So for me, at least, the evolution that I have seen from Python is that initially it was only a scripting language for playing around with things, and then with the big war started between Ruby on Rails and Django and all the other things, Python became a really important language for web development as well. Then I saw, as you may be already also listening this morning in the keynote, the boom that Python has in science-related things, and now we can say literally that Python is in most of the scientific projects, right? And recently, of course, we all have seen the evolution of AI and people using it. A language is the most popular, Python is the most popular language and everything, but we are still about to see what is next, right? So we have all these milestones, but what is next about it? And I believe that it will be related to the extensions and the way that we are using Python nowadays. So what is helping the current popularity of Python, in my opinion, is that if you go and check any of the famous projects, for example, I don't know, PyTorch, you will see there, maybe very small, but maybe you can read, there is a large portion of C++, C, Objective-C++, and other weird languages besides Python. If you go to more modern modules like Pydantic, they rewrote the core completely in Rust, so you see a lot of Rust there. There is this random database that I learned from it last year, also written mostly in C++. And even UV, that people also might know recently because of all the popularity of using it in the Python ecosystem, is mostly written in Rust. So, right? So we are seeing that Python popularity, it's kind of very tied to other programming languages. So why should we use other programming languages? Well, first of all, familiarity with new technologies. I've said that it's very cool when you have something that is not available in Python, but maybe is written in a different programming language, that you somehow can glue it together, right? You also get in touch with old software. When I was studying also, I touched a lot of Fortran code. Who here has touched any Fortran code? Don't worry about being a developer or anything. So it's interesting to see that you can bring all this old software to a current state with the help of Python, right? So you reach other technologies as well. You want to use other programming languages because Python is slow, that maybe this is something that a friend of you told you already. And one of the interesting things is that, to many people's surprises, is that compiled languages are faster than interpreted ones, right? So how many programming languages are there? We will not talk about all of them, of course, because if you go to the Wikipedia page, they will like go crazy about all, like even for each thing, so we will not talk about all of them, but only a few. And before starting, maybe who here was in the documentary the other day? Can see some hands? Okay, so most of you will be familiarized and will immediately recognize this code. I always like to show it because it's good to understand where Python is going now. Because this language, if you didn't know, it's ABC, which is Python inspiration. And you can see some Python kind of bits inside. Maybe the if, the indentation, maybe the for loop. That just looks very simple there. So you see how Python was born from these ideas modifying a few things. So the evolution of languages is something that we cannot stop, right? Well, if you want more reference there, of course, it was inspired in ABC. So to understand Python, I usually like to do this first impressions of which Python. If you saw yesterday's talk, for example, from Lisandros, he was mentioning that there are a few interpreters, right? So this is only a bunch, but there are many more. And there are Pythons written in many languages, in Java, in Rust. There are like reductions, there are forks that some people use. And it's very interesting. So for the sake of this talk, at least when I say Python, I'm talking about the standard implementation with CPython. So for understanding CPython, or the world of extension, very briefly, if you want to extend CPython, you go to the documentation. It's a very nice page, in my opinion. Right? And I read it, I understood many things. You can go there, and there is even some snippets. You can try it out, with, so if you are brave enough to touch C or C++. In a nutshell, creating this module in a different language like C has only a few parts. Like first you have, the core mechanisms that you want to have in your program and you want to expose, but also you have to define all the methods that your module will have, the module itself, and then initialization of that module. So if you want to write your first extension, this is the most simple thing that I could figure out. I know it's a different programming language, don't be scared. If you see there is one string declaration with some documentation. Afterwards is one function called simple hello that just returns a value that says hello from CPython. Then you have what I told you, the module definition, and then the initialization at the end. I know this, as I said, it can be scary, but you literally can copy paste this thing somewhere with the help of another file, which is a PyProject.toml. You can just create a wheel, install it, and execute it, right? At the end of the presentation, there will be a link, so you can get all the snippets that will be shown here, so you can try it out on your computers. And this is how you do an extension. So thank you very much. Now, of course, this is not the end of the presentation, because now it's the fun parts, like other programming languages, right? What is going on around? So it's tricky. There will be many things to learn. And again, try to get the main idea of these languages. You don't need to know everything by memory in order to start playing with them, because it's super essential for us to be aware of the existence of other programming languages. So the first one is something that is what I do for work, mostly, well, or used to maybe at the beginning, that is writing C++. C++ is, well, it's a language that is, some people hate it, some people love it, some people say it now is better, some people say that before it was better. But it's a language that is very old, and being old and trying to stay relevant requires for you to do changes. And also, if you are based in the philosophy that everything needs to be backward compatible and stuff, you need to make decisions, and there are keywords that look weird, and the code is very strange, but all programming languages can be also complicated as well. But we'll not go there. This is, again, the most simple snippet of C++. I hope everyone can read that I say, okay, they are doing some kind of import in other languages, and then a main function that prints hello world, right? It's a compiled language, so you need to compile it, execute it, that's it. So as I said, it's very easy to have, you can consider it like an extension of the C language, because now you have generics, functional programming, object orientation. It's also something that, a language that still have access to low-level memory manipulation, and one of the, of course, the good thing is that the performance, efficiency, and flexibility of the language, it's something that it shines. C++, even if you don't like it much, is everywhere, like most probably in the drivers of these devices, or maybe in your computers as a dependency of other things that you're running C++ applications and you don't know. So yeah, if you want to find some similarities, because that looks strange, again, super simple Python code that I hope everyone can understand, a class rectangle with a couple of methods, and kind of like a fake in a main function there, how you can call it, and then you have C++ next to it. Okay, first thing that you might think, okay, there is a few braces there, it's very strange, semicolons, but I hope that you can kind of see the similarities and say, okay, I understand that that's the class definition, and then declaring the modules and everything else. So I hope it's simple enough for you, right? So there are a few features of this language that are very close, or I don't want to say inspired in Python, but inspired by many other languages like Python. For example, one is that since the previous versions, now you don't need to specify the type of variable. So I know now in Python we are kind of evolving into getting to more like type specific for things, so things can be checked. But in C++, they decided like, well, in some cases, maybe let's have a special keyword that allow us to just to say whatever, and then at compile time you get the type, right? There is a different one, that for loop looks strange, but is similar to what you have in Python, so hopefully you can understand. There are other things, for example, there that you can use the enumerate that maybe you use in your for loops as well. Well, they also implemented something similar, so you can have that as well. And last but not least, one of my favorite features, because it's very close to Python, which is that even a print that you can format in a way, you will say, of course, the language should have all this. Well, not really, because the ways of doing prints in C++ before this was very strange. But okay, that's for C++. There is a few things that you want to say for the summary. So as I said, widely used. Sadly, they don't have an official package manager. There is a few features from Python, and it can be very complex sometimes. If you're interested, I will leave you a video there for most of the language that I will talk about. So it's very interesting to watch. So Rust, again, who here is doing Rust code? A few hands, okay. Don't be afraid, it's fine. We're a welcoming community, we'll not judge you. Rust is terrible. No, it's not terrible. It's very simple as well. Compile language, main function there. You don't need to do this weird import, but you still need to compile it. And if you have visited the website, you can see that performance, reliability, and productivity are like the fundamental elements of the language, and everyone is so happy about it. So next side to side for Python, we have here like a list. Again, I play around with the types, so it kind of resembles what we have on the Rust side, on the right side. And then you have a few operations, you know, the print, everything should be okay for you to understand that Rust code. Similar example that we had before, a class with something like that. First difference arise that we don't have classes in Rust. Well, maybe you're familiar with that, but yeah, they decided not to have classes, but still you can mimic the functionality of what we use classes, and then implementing that specific structure, and even extend it with some methods, so it's possible as well. So again, compared to C++, of course, maybe it's more simple, but you see a few weird things like this impl or fn for function or the ampersand around. But again, I hope you can understand that thing. So there's a few summary things is that, okay, ownership and borrowing are the best features of Rust. The tool, that it's an amazing tool, of course, as well. They can do everything with the same tool. Growing ecosystem, but this is still an evolving language. If you are interested, I remember a long time ago I watched this talk that is Rust for Python developers, in case you want to watch it afterwards, after the conference, of course. A different programming language now, SIG. Who knows SIG? Raise your hand. Knows. Don't worry, I will not ask you if you have written any code. Well, SIG also appeared, not around the same time, but as trying to solve the same problems. Here you have a little snippet of a hello world. I know for some people it can give you some Java nightmares or C# nightmare with all this standard.io, get standard.io, write, but trust me, I mean, there are a few quirks there, but the language itself is very good. So one of the things that they claim is that there's no flow control or hidden memory assignment. There are no macros. For some reason, the creator really hate macros in C. You have a few interesting features. You have a specific part of your code that can be related to metaprogramming. So you can have a compile time evaluation and then have some defer evaluation of some sections of the code. And the other very interesting thing is that they have inside a syntax to have tests within the same code. You can have a scope, saying tests, open brackets, and then you have the testing in the same code. So it's very interesting and convenient. Again, similarities, just to put it side to side for Python. Again, the rectangle example, you see there that, well, you need to specify the type. It's a bit weird because also there is no classes here. You need to use structs. But then everything else should be okay. I mean, you see there is a weird thing that the return type of the main function needs to be a void, and then you have the exclamation mark, but don't worry about it. But at least you have the feeling of how SIG will feel, right? Summary, as I told you, they claim to be faster and more secure than C. I mean, I cannot ensure you that, but that's what they say. They have an integration, very interesting integration that you can import C libraries and then start to using it. So this is very valuable for companies doing, I don't know, very C-specific things, that you can import these things without migrating everything, right? Should we pick up here? No. They also have the framework for testing, as I said, the comp time thing, and I leave you this talk there, which is kind of like the main SIG programming language talk out there by the author. It's really cool. Watch it out. And yeah, there's another feature that also I really like, but I think that they were trying to remove. I don't remember if they removed that. It allows you to cross-compile like with one line of code, which for C or C++ developers in the audience, you know how tricky sometimes it's a cross-compile thing. You have the toolchain and everything, but it was super amazing when I saw that and I tried it out. Often people, when I finish this presentation, decide, they say, yeah, but you didn't talk about NIM. So I'm adding one slide for the people who knows NIM as a programming language. Cool, yeah. So when I saw it, it was like, ooh, it's like a Python bash weird thing, but it's cool. It's another programming language, new ideas. You have different ways of implementing stuff, but I don't have a comparison just to give a shout out to the program because it's cool. I don't know, I discovered and it got my attention. And there are many other languages that, of course, I will have no time to do. So finally, how we can extend Python with them? For the first example, C++, let's remember what we had in C before. This is the same code. I haven't changed anything. And if you want to do it with C++, it's roughly the same because, you know, both languages are kind of compatible. So I'm just changing that and I'm including the string library in C++. I'm constructing a standard string for C++ and then returning that value. Super simple, almost the same. So you can even modify that, say, okay, I wrote some C++ code. And in SIG, it's a very, very, very simple approach. You first start to do the definition of all the objects, then you need to start defining your own functions, then you need to do the methods, and then you need to do the definition of the module, and then you do the initialization of the module. Very simple, right? And then, of course, you need the build specifics, so you cannot use setup tools. I mean, you use setup tools, but then you put inside some SIG command line specific stuff, and then you have your SIG extension. So then maybe now you're scared like, oh, you need to do everything by hand in this programming language? Well, you can, but luckily for us, there is one essential part, which is something that I work very close with, which are binding generator. So in a nutshell, little code that help you to not writing the whole thing by hand. I will take some water for suspense. Good, binding generator there. In a nutshell, you have some code, a magical box, and then you get your Python package. That's the most simplistic approach that you can understand what a binding generator is. The first one, if we start with C++ again, and I think one of the most popular ones is PyBind 11. It's very cool because it's header only, so you don't need to have some sources around. It's inspired by the previous mechanisms to generate binding, which is from Boost, and a very famous library. Well, it's compatible with many C++ things and supports many compilers. This is the important part, the code. You have your very simple function, add two numbers. I hope everyone can understand that. And then PyBind 11 allows you to declare the Python module within the same code. And you see there, just put the documentation, the definition of the method, and that's it. You compile with those with those magical commands there at the bottom, and you have your first C++ Python module. I'll leave it at that. Very convenient, right? The same creator said, no, this is maybe too much. This is too bloated. Let's do reduce and only focus on a few specifics. So the person developed Nanobind, but again, super small, exposes types around, which is very convenient. It inspires in the other one that I showed you before. And the footprint of this thing is ridiculously low. So it's an amazing binding generator. The code, very similar to what you saw before, right? But now, you need to compile things instead of that weird command line with a few thematic things. The other one is something that I work close by because it's what I use in my company. It's also inspired in voice Python. We use it for Qt or Qt. I don't know if you know this framework, very old framework, again in C++, for the Python module. And you don't need to alter the library code. This is very important. For some people, they ask me, like, what do you mean by that? Large project, as you might know, even in Python, imagine if now if I tell you, like, grab one of your biggest projects and you need to add only these 4 lines to each one of your files. Do you think that the rest of your team will be happy? No. So for that, The idea of this is mostly that you will not touch your code, and you will write a file separately, and the things will automatically be connected, so you can leave your amazing library there on the left side, the test CPP, without touching anything and adding all this declaration. Very simple. You should give it a try. So now let's go. Yesterday in the lighting talks, some people were mentioning this generated talk about PyO3. Maybe you know PyO3. Who knows PyO3? Okay. Less hands than Rust, so it's interesting. So it's Rust binding for Python. It's a very cool thing because it includes many tools and also an interpreter inside, and it relies on a different project called Maturin. You see there is a very, again, simple Rust code. So you include some, do some kind of import of PyO3. You have your sophisticated function there, and then you declare the module like that. Most of the magic here is done by this weird pound key on the top of F and add. So if you see here, this thing is a procedural macro, and that's the thing that do the magic that, it's like a decorator in Python. So do things and, generate some code that in order to generate the thing. And for SIG, the one that I was showing the example with the huge files and many lines of code, there is also something very interesting. So you have there, they have a special plugin for doing PyTest. Again, they're compatible with CompTime, which is this feature that I told you before about having compile time deferred evaluation things. And they rely on poetry, that also maybe you know poetry. Has anyone used poetry? Keep your hand out. Do you like poetry? I knew there's always people, but I don't know, it's not a bad package. I mean, there's always like people that don't like things. But this is how you do it with SIG. Oh no, I lost Ege. Sorry, Ege, for being... No, that's just kidding. So it's very simple. See, I mean, all those lines of code, but magically now SIG PyDAS will just require for you to add 2 lines, and then in CompTime, which is the feature that we were highlighting before, and that's it. You have your first SIG-based Python thing. So it's very convenient, see? There are many more, of course, binding generators. Just pick one language, go to Wikipedia, and for sure you have binding generation in that language. The majority of this is inspired in C because C is a very good language to glue things around. And from the case of C++, it's in such a widely used language. There, I don't know, I think last time that I did a table, there were like 15. And the process is sometimes, though this example, of course, is to show you how simple the most simple case can be, but things can get very complicated. I will not scare you because it's after lunch session, so I didn't want to show you scary code, but in a nutshell, so you have why this complexity, or where this complexity comes from, is because you have specific concepts to the languages. What is a decorator in Python in C? Well, you would say, well, it's just a function that is inside a function or whatever. You can try to find abstractions, but there are things that you don't know. Like for the people that know C or C++, what is a void start in Python? You will say, well, it could be something, but it's difficult, right? So all these decisions, because people writing Python code, they don't want to write weird things from other languages, right? So you need to take care of all the specific concepts. Data types. For the people, the few hands that I saw about Rust, you tell me which one I need to use for declaring a string. Like there are like, I don't know, 8 type of things to declare like a characters kind of arrays. So which one of those do you use? It's difficult. Pointers, again, not all languages have pointers, so how do you make an abstraction out of it? Memory management. When you create something in a binding, let's talk about like memory. Who owns it? The Python module that you created or the C module under the hood? You need to make those kind of decisions like, oh no, for this specific one, now it's Python, so it can be garbage collected later or something. Or no, it needs to be alive by C. And threads, always problem with threads. Async, it's always problem with async because interpretation. The GIL as well, so even now if people remove it, this is still an issue because you need to stay compatible with those things. And uses this thing, I mean, I like that Python has new features, but at least as a library maintainer, it's a very problematic feature for me because in a nutshell, this for many modules will mean like, oh, Python has no GIL. So now you need to implement your own GIL for your own things and processes that need to be like that. So yeah, you need to do logs and stuff, all those things that you were maybe learning in computer science classes that you thought never will apply. Well, you need to do it. So it's not fun. And there are many other things and complicated factors and here and there that you need to take care of. So going back to the current popularity of Python, as I told you before, rewriting code in Python, Python code in a compiled language will make the performance go very, very crazy about it. But I really don't like, and usually the message of this talk is like, when you see these things, I try not to be surprised about, oh my God, I cannot believe it's faster, because it's very obvious about it, right? So I believe that we should kind of rewrite this thing, not only because things will be faster, but just to uncover and try to bring more features to the language. Right? So as I told you, I remember when a few Rust tools were around on social media and stuff, people were losing their minds, like, oh my God, I cannot believe it's faster. And everyone was like, of course it's faster, it's a compiled language. But anyway. So how difficult could it be then? I thought maybe I can be famous as well and have many internet points. And I thought a module that you know, glove. Everyone knows glove from Python, right? Maybe you don't use it, whatever. And I thought, in C++ you have something called standard file system that you can iterate directories. So again, I took literally the same snippet that we had at the beginning, and then I said, instead of this printing hello, I will just mimic there the recursive operation of glove to go around. And then I tried it out, and I had some numbers. And I have 1,000 directories with 1 million files in total, and I thought, okay, what if you use glove? That's the time, at least the base time that I had for things. If you use patglove, if you're using pathleaf, which is a very cool library, you get a lot of performance as well. And don't worry about the non-recursive one, is because I am transforming into a list, but the recursive one is the interesting one. And then I wrote it in Rust. It was so fast, and I was like, you know, I can be famous, put it on PyPI, that's it. But then I did it in C++, and it was faster in C++. And then some people I remember in Lithuania told me, like, yeah, I know, because it's just the overhead of PyO3, because it's a binding generator, whatever. I said, fair enough, I will do it with a binding generator. And yeah, there is an overhead, but it's still faster than Rust. So then you want to say, why people is not using C++ there? Well, I don't know. But what not to do with this information overall is, as just to finalize the talk, is that please, when you solve one problem, not everything needs to be exposed to Python. Not every single feature needs to go around. You don't need to know all the programming languages, and don't try to force things that they don't work that way to work that way because of reasons. So don't see everything as a nail when you have so instead of a hammer, you need to try to understand that for our daily life, many of you, of course, are the software developers. You know that even if we love Python, there are other languages that bring us more things to do. So we need to embrace all the languages and try to have a proper solution. So as I said, we need a combination of programming languages for everyday thing. So what to do with this information after all then is just to help the Python ecosystem to keep growing. And a topic that I think that I will not have time, that I wanted to talk about if Python has a successor, but I will just go, don't look at the slides, right? So yes, PyPy, Rise Python, Mojo code, it's a really cool code, by the way, if you want to check it out. But yeah, so with this help, I don't think, maybe the next things, in my opinion, will be based in a new extension or something that we can unlock from a new programming language that has an amazing feature and maybe want to expose projects to Python. And I don't know, maybe in a few years you will give a talk about and say, it's like, oh, how people thought that Rust was a solution to all our problems, and now we have this programming language that it was. So the final thing just to say is that extending Python with other languages keep the community very active, in my opinion, and also motivate some discussions that we can have here. I mean, you saw yesterday when I shouted Rust to the lighting talk, people started to laugh because, you know, some people were booing at Java and other things. So it's discussion going on. But the most interesting part of me is that when we're extending Python with other languages, now we get for free new people, new cool people, and we're extending our own community. So yeah, now it's your turn. You have all the tools here to just play around, maybe try it once and have a Python extension. And I hope you learned something new today. Thank you very much. We have time if you want for a question.
Does it work? Oh, perfect. Thank you so much. That was fantastic. I think we have time for a very, very short question, if we have one in the audience. Okay, I see one here.
It's also from there.
Yeah, hi, thanks for that. Last time I tried to extend or embed Python was a year or two ago. Actually, embedding Python in Python in C code, right? The most complex thing I had to do is actually getting the appropriate C flags within Python 3 config. And I discovered, I discovered that Python 3 config doesn't really work with visual environments. Is it still the case? I mean, if I have to embed the Python, it has to be like the system path? which is...
But embedded in a different application, you mean?
In the C application, yeah.
No, it doesn't need to be the system path. At least I have, for example, one application that we embed, we put a Python interpreter inside an application, for example, and the other way around as well. But what do you mean like system path itself? So the Python installation in your system,
I create a virtual environment, Python 3 config minus flags, LD flags, or
you mean the
whatever.
flags.
It doesn't, it only points to the system level. So if I want to isolate a new library, I don't have this available to see because it points to the system level. And I was just looking at the issue now on GitHub, it looks like it's still open. So that's a major deal breaker.
I don't know, but if you show me the issue, we can figure out.
Perfect. I'm sorry, this is time.
Okay.
But Christian will be around, so feel free to go chat and ask more questions. So now we reconvene in 5 minutes. Time for a short break. Hi, everyone. Welcome back. So next up, we have Daniel Zocche, who is going to talk to us about why you should learn Rust as a Python developer. And I'm really looking forward to know why. So a round of applause for Daniel.
All right. Can you hear me? All right. So, yeah, as she just said, I'm going to tell you why you, as a Python developer, should learn Rust. But before I get too much into that, I want to give you a little background about my background. So I'm a software engineer at Sentry, which, for anyone who doesn't know, it's an error and application monitoring product. I've been working there for 2 years. And when I started out, I was working only on the Python SDK. But then later, I ended up learning Rust so that I could take over maintenance of Sentry CLI, which is a command line utility written in Rust. And, well, I really enjoyed that experience of learning Rust. And nowadays, I really enjoy writing Rust. And I basically want to share insights from my experience being a Python developer who learned Rust, and basically tell you about some of my favorite features in Rust and why I think you should learn it. So yeah, this is kind of an overview of what I all want to talk about today. And the first thing I want to do is basically do kind of a high-level overview of the difference between Rust and Python. And so I think one of the main differences between Rust and Python, of course, Rust is a compiled language and Python is an interpreted language. And Rust has this emphasis on safety and reliability, which means that a lot of errors that in Python would end up being runtime errors actually get caught at compile time in Rust. So this is really cool because you can avoid shipping bugs in the first place, and I think everyone likes that to not have bugs. So this is just one example of where you can kind of see Rust's benefits, and that's in type safety and specifically null safety. So this kind of sets Rust apart from Python and also other languages like Java or C, C++ that you might be familiar with. So let's take this snippet in Python, which you have two variables, A and B. You set A to none, B to 0, and then maybe you have some code where you would expect A would get initialized to some value. But for whatever reason, its value remains none. And so when you try to compare A and B on the last line, of course, we get a runtime error, and that's sad. But in Rust, if you try to write basically an equivalent code snippet, this actually won't compile. And the reason is that in Rust, you can't just set any value to none or null. It has to be explicitly typed as an option value, which you would do like this. And then if even if A doesn't get changed later, actually the compiler won't let you do this comparison because it knows that A might be none, and you haven't handled that case properly. So the Rust compiler would force you to write this code instead, and this if statement, all it's doing is making sure that A is not none, and if it's not none, it's going to take out that inner value and use it for the comparison. So in this case, if A is still none when we reach this if statement, we'll just skip over that code completely, and there's no problem. So it works at compile time and at runtime. And this basically leads me to kind of one of the, I think, fundamental philosophical differences between Rust and Python, which is that Rust involves more upfront effort because you're forced to handle all of these cases that you could skip over when you're writing Python. But compared to a language like Python, you have fewer runtime errors. So that brings me to the second topic I want to talk about, which is more generally overviewing Rust's safety and reliability guarantees. So these are really, I think, what make Rust unique compared to a lot of other languages, and especially when compared with a language like Python, which I feel doesn't have so many safety guarantees. And the first thing I want to mention that I really like about Rust is explicit mutability. So by default in Rust, values are immutable, which means that once you set the variable, and if you didn't declare it as mutable, basically you can't change it anymore. And so for this, I want to show you this Python snippet where we have a list of numbers and we have a mystery function. We don't know what the mystery function does right now. We don't have access to its implementation. And what we want to know is what is the value of numbers at the end of this code snippet. And it could be anything because we don't know what mystery does. And lists in Python are mutable, so mystery could make arbitrary changes to that list. Might not necessarily be a problem, but this is just how it works in Python. On the other hand, in Rust, if we write this equivalent snippet where we set numbers to this vector, it's called in Rust, of 4 numbers, and then we pass it as a reference, that's what this little and sign means, to mystery, we actually know for sure that the value will be unchanged. And that's because, of course, we didn't declare numbers as being mutable. So let's say we did want to give mystery the ability to change numbers. How would we do that? Well, if we want to mutate something in Rust, it has to be declared mutable. And we can declare a variable as mutable by using the mute keyword, which I've done here. So now you might think, this code snippet, we don't know what numbers is at the end because mystery could have changed it. But actually you would still be wrong because mystery is getting an immutable reference because we just have the and sign and then numbers, and this means the reference is immutable, and so the function can't modify anything at that memory location. So references also need to be declared mutable explicitly, so it's very clear when your code can change values. If you want to do that, you would basically need to rewrite the code as follows. The key part here is the mut after the ampersand, although I also changed the function name to indicate that you would need a different function signature basically to be able to take a mutable memory reference in the first place. And so this explicit mutability means basically you're not going to get any unexpected changes to variable values. So you could imagine in Python, maybe especially if you're sharing an object across different parts of your code, that some part might make some change when you didn't expect that in another part of your code. So this is enforced in Rust. The next topic I want to mention, and I think Christian also mentioned it in the previous talk, are ownership and borrowing. And this is another unique feature in Rust that allows us to ensure memory safety at compile time without garbage collection. So this is really cool because we can't have memory leaks as easily as in a language like C, but at the same time, we don't have a garbage collector which adds like a performance overhead. So how does this work? And this is maybe one of the more complex subjects in Rust, so I'm going to do my best to give you an overview, but I apologize if it's a bit advanced. I will have references later so you can read afterwards. All right, so ownership. Here I have a little snippet where I've made a variable hello, and I'm assigning it to a string that contains hello world. What you need to understand about this string from is that it's going to allocate an area of memory on the heap to store this string. So if you're familiar with C, it's doing like a malloc, basically. And then hello is now the owner of this heap allocation, it's called. Every memory allocation has one owner in Rust. Now we pass hello to foo. And this time, you notice there's no ampersand symbol in front of hello, so that means we're transferring ownership of this heap allocation into the foo function. So this then means that foo can do whatever it wants with this memory. It could mutate it, it could do other things, it could pass on ownership to somewhere else. It has total freedom now to do what it wants with this heap allocation. But in order to make sure that we don't leak memory, the Rust compiler, as soon as the single owner goes out of scope, will free that memory allocation. So this code here will fail to compile, and the reason why is that when we call hello and give it, or when we call foo and when we give it ownership of this string allocation, basically at the end of foo, Rust drops it. It frees that memory because the owner is done with it. And so Rust's compiler has something called the borrow checker, which will know that this has gone out of scope and give us a compile error when we try to print hello. So how could you fix this? One way would be to clone that string. So this will create a new memory allocation on the heap with an exact copy of the original string and pass that to foo, so foo can do whatever it wants with it, but we still keep ownership of our copy. Another fix you could do if you don't need like this full access to the memory is you could pass by reference, which in Rust we call borrowing. So now you would again need a different function signature that can accept the borrowed reference instead of the owned data. And so the two function signatures might look like this. And so now I want to give you maybe a little more information about borrowing, because that's also a very interesting subject, because of course we have always one owner in Rust, but then how many borrows can we have at the same time? So of course we already saw both of these examples earlier on the explicit mutability section. In the one case we have an immutable reference, in the other case we have a mutable reference. In both cases there's only one borrowed reference at a time. And both of this, like this is allowed, it works. What if we want to have multiple borrows though? In the case of immutable borrows, this is okay, because you could imagine a bunch of people can be reading the same memory, and they won't interfere with each other because nothing gets overwritten. So in this example, I've added the second line, which is going to borrow numbers. It's specifically going to get a reference to the first two elements. It's pointing to the exact same memory as the numbers vector is. And then we're going to use that borrow again on the final print line, where we're going to print just those first two numbers. And then in the middle, we're going to pass a reference of the entire numbers vector into mystery. This is fine because mystery can't do anything unexpected with numbers that would modify the first two numbers in some unexpected way. But as you might be guessing, if we were to have an mutable and an immutable borrow at the same time, this would be a problem. So again, we have the same first two lines, except now numbers is defined as a mutable variable. We have this immutable borrow still of the first two numbers, but in the middle, we're going to try to pass basically a mutable reference to mystery mute. And the compiler won't allow us to do this, of course, because that mystery mute could alter the values in first two numbers, even though that's supposed to be an immutable reference. If that was the only thing that could happen, it wouldn't maybe be that bad. But the other thing that could happen is because this vector is on the heap and it's a resizable data type, we could actually either shrink the vector or grow it so much that we need to reallocate to a new memory slice, and that would invalidate the original reference we have in first two numbers and lead to a segmentation fault when we try to access it on the last line. And so for the second reason, actually, we also can't have multiple simultaneous mutable borrows in Rust. We can always have either just one mutable borrow or as many immutable borrows as we would like. That moves me into the final safety thing I want to talk about, which I don't have an example for. I instead have a happy Rust mascot there. But it's called fearless concurrency, and basically it means that in Rust, the compiler is able to check that anywhere you have some data being shared between threads, that the data types you're using are thread safe. So if your Rust code compiles, it's thread safe. You don't need to worry about anything else if it compiles. And this is like really cool because you can avoid a bunch of concurrency bugs in Rust with this. All right, that brings me to the third topic I want to talk about, which is, I think, a great benefit of Rust, and that's all the tooling around it. So a lot of this tooling, as Christian also mentioned, is bundled into this cargo command line tool, and so you already have like this one way to access all these tools I'm about to show you. So yeah, it's really cool that you have this ecosystem in Rust, basically. And the first thing I want to talk about are the compiler warnings, because these are very informative and friendly, and they are really a great help when you're just starting to learn Rust. So let's take again this sample I showed you with the immutable and mutable borrow. If we try to compile it, we get this error. And so you can see there's a lot of colors in there to help show where the problem lies. We can see, it looks really similar to my slides actually, because I think I basically based them off of this, but you can see it shows you the immutable borrow, it shows where you use that again, so you can see that it's occurring simultaneously to the mutable borrow, and then that's where it tells you, okay, this is not allowed, you need to fix your code. So, Rust compiler is amazing. Next thing I want to mention is the Clippy linter, which is a standardized linter in Rust, and it has standardized default rules. And this is really cool because basically it means that any Rust code you see out there is very likely to have gone through this linter, and so it's very consistent. And the lints are really exhaustive. I think there's like 700 or more lints, of which a decent number are enabled by default. And so here I'm just going to show you a couple of them. So let's say we have this function called isPositive, where we try to detect if a number is greater than 0. If it is, we return true, otherwise return false. Of course, we could just return the Boolean comparison directly, and the linter will complain about this and tell us that we should write this code this way. But actually, this can also be improved. Anyone who knows Rust would know that the return statement is unnecessary, and if we just remove return and the semicolon at the end, this will actually just return that value, and the Clippy linter will tell you that. So even if you're writing Rust for the first time and you don't know about this rule, Clippy will just teach you on the spot, and then you know for next time. There's, as I said, a lot of lints that are enabled by default, but also there's some optional ones which you can enable depending on your needs in the code base. And I have this code base, Sentry CLI, where we've had some new contributors lately, and I've found myself enabling quite a few new lints because I would notice something in code review that's unidiomatic, and I'm like, there might be a lint for that. I check, half the time there is a lint, and I just enable it, and now I don't need to comment in code review and watch for this. I just push it, I update their branch on the new branch, and then their CI fails, and then they need to fix it. No arguments. Frictionless code review. The next really cool thing that also helps in code review is Rust format. So there's standardized formatting for all Rust code. This is also, of course, built in through that cargo command line, as I mentioned earlier. So we have this very badly formatted function. Rust format will fix it like this. that's cool, but I mean, it's not quite enough to be really special. So I think the special thing is that this is also very opinionated, which means that there's always sort of like a correct way to write any type of Rust code, and this avoids like these ideological arguments of what should we do, and then people just get mad in code review. So like either of these where we have the opening brace on the next line, or where we've put all the arguments onto separate lines, in this case, are not the correct format in Rust, and Rust format will just correct them to the correct thing. So you can put this locally in your IDE, you can enforce it in CI, no more arguments, just writing code. Great. Yeah, all of these tools you can have directly in your IDE via Rust Analyzer, so like the compiler warnings and linter warnings will all just show up as you're typing the code, which is really nice. You don't need to run the compiler, you just see it right there. So, lastly, I want to tie it back to the original topic, Python. Why should you, as a Python developer, learn Rust? And I think the main reason, both of these languages have their own advantages and disadvantages. And when you know both of them, you can optimize which language you use by use case. So Rust is great for stuff like performance, when you have something that needs to be reliable and ideally without bugs. System programming, these are things you can do very nicely with Rust, but the trade-off is you're going to put in more upfront effort to get these fewer bugs at runtime. Python, on the other hand, Python, on the other hand, potentially you can write it more quickly, but there might be more maintenance effort in the end. However, it's really good for quick iteration, simple scripting, and also the data science libraries are don't, I think, have an equivalent in Rust, so this is a huge advantage of Python over Rust. Next thing I want to mention is Rust is enforcing a lot of safety concepts, and if you learn Rust through the Rust book, which I'm about to mention, you'll also learn about these safety concepts, and they're good practice in languages like Python as well. And I would even argue that understanding these concepts well is more important when you're writing Python than when you're writing Rust, because if you write Rust, you have the Rust compiler that will warn you and tell you when you did something wrong. In Python, of course, you don't have this. And that brings me to my final point, which is, even if you're never going to write a line of Rust, I think learning Rust will help you write better Python code. So if I've convinced you, I would recommend learning via the Rust programming language book. People also call it the Rust book. It's the official book, and it's my recommended resource for how you should learn. It's how I learned Rust. And if you scan this QR code, you'll get a link to that book, and you'll also see some other links that are relevant to this presentation, like the slides or my LinkedIn. So scan the QR code and learn Rust. Thank you.
That was fantastic. Thank you so much. So we have a lot of time for questions, actually. So you can already start thinking about your questions. Any hands here? Ah, perfect.
Hello. You mentioned the performance differences between Rust and Python. Do you have any metrics, side-by-side kind of things to indicate?
I don't have any metrics prepared, but I would say Rust is a compiled language. It doesn't have the garbage collector, so it probably depends on what you're doing. Like if your code is I/O bound, then maybe doing it in Rust doesn't matter quite as much. But I think you would really have to see, depending on your exact use case, what.
So where typically would you expect better performance?
Sorry?
Where typically would you expect better performance?
I mean, probably like My guess is like a CPU-bound task is probably more likely to.
Okay. Thank you.
I mean, you also see like a lot of these libraries in Python, these data science libraries, are written in languages like C or Rust, which are compiled and therefore faster, and then the Python ends up being more like a interface for calling that code.
Perfect, thank you.
So what does that mystery function do in your program which you showed of Rust?
It can do whatever you want to imagine it does. That's
What does that mystery function do in Rust?
It's a made-up function. It can do whatever you're imagining it does.
It's like random module in Python.
No, it's a made-up function that does something and we don't know what it does. It's a mystery function. We have no idea. It's fake. It's made up. It's not in the standard library. I'm just using it for an example.
Okay. Okay.
Thanks, very informative talk. I have a lot of experience with Python and pretty understand what we can build with it, but have no experience completely with Rust. Maybe can you explain a few words, some basic or common cases where it can be applied?
I mean, it's a general purpose programming language, so basically anything you can do in Python, you can also do in Rust, but I guess the use cases where I'm familiar at being used very often are performance critical code paths. So I know at Sentry where I work, our event ingestion pipeline is written in Rust because that needs, we receive millions of events probably every second, and we need to ingest all of that data very quickly. So we wrote that in Rust so it would be highly performant and resilient. You can also use it in systems programming, kind of as a replacement for where you would use C or C++ traditionally. But really you can do whatever you want. Like Sentry CLI is also written in Rust. I don't think there is a strong reason why it needed to be written in Rust and not in another language like Python. It was just the design decision when that project was started 10 years ago. So. Does that answer your question?
Yeah, thanks. So it's mostly what I understand. It's the high-load system with whereas performance is very important.
Yeah, that would be a general use case, but you could use it wherever, really. Like, yeah, it's flexible.
Thanks for answering.
Yeah, of course. More questions.
So I'm more used in interpreted languages, and my main, the image I have from Rust is, have you found it difficult to decide who should own something? Because that's a decision, I don't know, when you're just sketching out a solution to a problem and you don't really know what everything should look like how do you decide who must own what and whether you should give full mutable references or just a copy or something? How do you decide that in the beginning? Because there is really a phrase in, everyone says, let's rewrite this in Rust, but I haven't heard so many people say, let's think of this in Rust. It sounds like a tool, deciding these things up front sounds very hard. What is your experience with these decisions?
So my experience is also difficult with this because Sentry CLI is a old for Rust code base. It's almost 10 years old and the language has evolved a lot. And I think also a lot of original contributors were using Rust for the first time, so they also hadn't really thought about this. And we have a lot of places where we're copying data that doesn't need to happen that way. What I typically do when I'm writing Rust code is I try to make the owner be the thing that is lasting the longest, and then everywhere else I just use references back to that original data. But you might also have some state where you want everything to be owned, and then it could be over there. I don't know. I don't have the best practices for this right now, I think, but But per your second question about where should it get a mutable reference versus an immutable one, I think the Rust compiler actually can help you with this, and it will tell you like if something has been declared immutable but you're not actually mutating it, and it will suggest, hey, maybe this could be immutable instead. Yes.
Sorry, that's all the time we have for questions, but feel free to grab Daniel, he will be around. So let's give him another warm round of applause. So 5-minute break, and then we'll reconvene again at 3:10. Yeah. Okay. We need 2 minutes. Is sponsored by Yodek, and I'm very glad to introduce my former co-worker and amazing individual, Christos Georgiou. So a warm round of applause.
Thank you, everyone. If I talk too loud and someone wants to sleep, let me know, okay? So, I'm Chris, or Tizot, or Tzot, whatever you want. I've been with Yodek for 8 years. When I joined the company, I was the 6th employee. Now we're more than 150, so we've lost count. What else? My first Unix account was opened in 1987. I'm older than I look. And the first time I saw Python code was in 2000. That's more or less the basic stuff you need to know about me. So, what we are going to talk about. Yep. Migrations. Who among you have ever worked with Django migrations? Can you? Yeah, great. In any case, I will give a small heads up so that everyone knows what we talk about. Well, you have your code, which has versions, is under source control, usually Git. And you also have a database server, which must be in sync with your code. Now, the device we have for space and time traveling is Git. You can go back in time, go forward in time, or move 2 seats to the left and have the same version of the code. The database does not work like that, so the easy answer is you record the changes to the database schema as code, which is, along with the other code of your application, stored inside Git. So, when you have to, so you have your code and the changes to the database that go with it. If everything was perfect, then you would have a straight line from the past to the future, and you could go back to any point whenever you want. However, you know, we have branches. We have things that work in parallel, which means that if you are in C2, the branch C2, and you want to go back to B1, you can do it with one command in Git, but in the database, you have to undo the changes, C2, C1, A2, A1, so you are before B1, and then apply the change for B1. This is the way to change branches and have your database follow the changes. Well, what you can do is do it by hand. You see what I'm here, those files changed, so I got to go back there, etc. Obviously, this can be automated. Also, another thing that is important is that not all changes, not every migration file which is stored in by Django migrations, or South as the module was used to be called, they're not all about the database. Some information is only Django. So like, for example, when you have a default on a field, Django does not apply the default as a database change. The code itself, the framework, manages the default. So you might change the default, and by default, the migration framework would make a new migration just to record this change. This is not a database change, so you don't really have to move back the database in any version. Another thing is you might have choices in a field which is used by in the admin framework, which we call Y console, but it's not important. So you can, if you make a change in choices, you have a field with choices, and in the admin framework, you would see a drop down with the choices. And then you add a new choice. That would cause a new migration to be created, but it's only for Django, it's not for the database. So one thing we do is we store the choices in another module, which is accessible both by models.py and by the migration itself. So they both import the same setting. And if you change the setting in the imported module, then both the models and both the migration show the same content. So Django does not create a migration for that. Now, another thing we had, especially with Django 1.8, we used to work with Django 1.8 in the beginning, and with Python 2.7. Before we managed to go to Python 3.8 and Django 3.2, and we managed for some months to have the exact same code base for both versions of both Python and Django. There was a bad algorithm in Django's migration management. So we used to merge migrations. This is the official way to, if you have one migration and another migration which are not related, you're supposed to make a merge migration that joins the two. And we used to have a lot of merges because we had a lot of parallel development. The thing is that with many merges, especially if you had references from one Django application to another, that algorithm used to inefficiently count all possible paths in a list. The code on the left is from the Django migrations framework. There are two prints marked with a comment with my username. And you will see on the right a sample run that we arrived at a point where those collected migrations reached up to 35 million. So migrations used to take a lot of time. We made a patch for internal use because by then 1.8 Django was already out of date. So we made the patch for our use until we switch over to Django 3.2, where the algorithm was corrected. And so this is one data point that affected our choices of procedures and tools. At first, we thought, okay, merges are not very efficient. So we thought, why not make all migrations serial? It's kind of Git rebase, but not exactly. What we did is we have a registry where each one goes and places dibs. I want this number of migration. And they use that number in their branch, pointing to whichever was the last migration before the branch. We do that so that we have one migration next to the other. We also try to have self-sustained migrations, meaning it goes forward, but it can cleanly go back. We have tools that help us. For example, if you add a table and then you have to go back, the table will get dropped when you get back, but you will also lose the data of the table. If you had something you wanted to preserve when you come forward again, we also have tools for that. You mark the interesting data in your migration. We have code that creates two functions. In this case, one function is called save data before updating parent folders on the left and the bottom, and the top right is the restore saved data, if any. This is an actual sample for one of our migrations, which has also the guidelines, because you have to keep in mind that when you move forward, the order of the operations is on the left. But when you go backwards, the order is reversed. You go from bottom to top. And given that Postgres, which we use in a single transaction, does not allows data changes only after schema has changed. If you change a table, you cannot add data to it or to anything else in that transaction until the schema change has been committed. So we make sure that all changes to the database tables or fields, columns, happens before we make data changes. So this is another point which we try to enforce, is that each migration is self-sustained and has the correct order of operations. So to handle all those going back and forth, we made some tools. One tool is switch to. You're in a branch and you want to move to another branch. So you say switch to the target branch. Well, the first iteration of switch to did something simple. Just compared, I'm in this branch, in that branch, and then we have those commits that affect migrations, and we had the option that if someone added a comment with switch to ignore, then switch to ignore that commit because it was a change like the ones I said earlier that does not affect the database. But we've usually forgot to add that comment. So the switch to algorithm changed a little and said, if any commit has switch to ignore, then don't do the operations, but that wouldn't work because obviously, once there was a single switch to ignore, then you wouldn't take account of all the changes. So that didn't live for long. And we ended up with the following option. We take all migrations that have changed between the two branches, we parse them, and we make an AST. We remove any operation that does not affect the database, like changes of the choices of a column. And then we compare the two trees. And if there are changes, then we know we have to go back to the immediate parent of both versions of a transaction. An example is V75 is just the name of the current release branch. So if I am in master currently, and this morning actually, when I finished the presentation, and you have to go to V75, there's only one change. There's a migration in V75, which we don't need to do anything else. We just go forward. And below is the output of the next tool I will describe, which checks exactly that and does the migration. If you go back to master, then obviously you have to go to the immediate parent of both the versions. So this is why the tool as output has the commands you need to run. It doesn't run them because we want to check, we want to make sure, and we don't all of us use the same commands. And another example, if I go to 4 releases back, then obviously the changes are much more. And you see, many of our Django applications need to go back even one in the beginning, 0. In the end, you see auto-migrate, which is the other tool I'm going to talk about. Actually, since we put migrations in a line, then it's possible that I am at migration 1. Someone branches and make migration 2. They got dibs on 2. And later, we add another one, which is 3 in the main branch. So the main branch knows 1, and 3 is its immediate child. And then sometime, the 2 from the other branch will get merged. So we will have in the main branch, migration 1 applied, migration 3 applied, and then 2 appeared, which is not applied. Django migrate, manage PY migrate cannot handle this. Says, okay, you have 2, it's not applied, but 3 it is. So we did auto-migrate, which does a little magic, like finding what needs to be hidden so that migrate works. So in this example, I should hide the 3, which is already applied. So Django sees I have migration 1, it is applied. I have migration 2, it's not applied. I can apply it, there's no 3. And then 3 reappears to continue the process, should it need to be continued. An example of that is actually, we moved to a branch where 320 appeared. So 318, the previous one, existed. 321 was applied. So it did exactly that. It hid 321, migrated to 320, then it showed unhid 321 to make sure that everything is complete. It works. It's our way to handle the less possible hassle for migrations. So in summary, we make sure that our migrations are self-sustained. You can move forward, you can move back, because we often need to go back and forth in change branches. So we check the PR or whatever. We decided that merges were bad. They're not bad, but there are cases when they make things much slower. So we found a mechanism with a registry to avoid merges. And then we had a tool that handles the case where you have migrations and then a branch gets merged. So a migration appears in the middle. So you have to hide the rest, apply that migration, show the rest, and repeat the process should the need be. That's my grate, cheese grate. We will have a Q&A session, as far as I know, but how much time do we have? Okay, this is good. Well, I was told by our HR department that to remind everyone that we are interested in people that would like to work with us. We have a very good environment. If anyone objects, they will get fired, so believe me. So this was an after credits slide. We really want people that want to work with us. We really are a good environment. I usually, when I say stories to my wife, she gets mad because she's not in a very good company. And yeah, that one on the bottom right, it was AI created for me. The one on the top right is the one that says we want more developers. The one on the bottom is that guy over there, which used to be the backlog manager whenever we had meetings. And now he's the official closer of meetings. There's no meeting closed unless he says, yes, sir. On the bottom left is some people's idea of fun, because I said whenever we work in our branches, I don't want to say every time in what department I work for as if I am a client. So they added my face for the skip button. On the top left is because we are so great a company, we almost have a religion. We make human sacrifices to Cthulhu so that we have a strong year. If you come and you're not a very good developer, we can sacrifice you to Cthulhu. So that's it. I hope it was useful. Any questions? Come here.
Perfect. Thank you, Christos. Warm round of applause. We have time for questions. Any questions from the audience?
Yes, please. Yes, please.
Ah, perfect. I can come to you.
Thank you very much for the talk. I have a question about the package. Is it open source? Can we use it in our projects? Or?
We can do it. We'd have to clean up the code, remove 4-letter word comments, you know. But we can open it.
Thank you.
Perfect. Any more questions for Christos? Ah, perfect.
Hi, thanks for the talk. How does the registry work? Is it like
It's a simple Google Sheet where we go and pick the next row and pick the next number, mark your name, so maybe comment what is it about. So everyone knows what is the next available number.
We have more time. Any curiosities? I have one actually. How bulletproof is this approach? If you're running like a server and you want 0 downtime?
This approach, if you follow it religiously, and if you use the latest version of the tools, important, then it works. Now, I mean, after all the code has been run and we found missing parts and we fixed them, now it works.
Audio. Ah, perfect. Good to know. So, any final questions for Christos? No?
Any questions? If I don't know the answer, I'll call my wife. It's all right.
Part-time comedian, as usual. Perfect. If not, let's thank him again.
Thank you.
And we can go to the coffee break now. Thanks, everyone.
Καλή ήτανε.
Welcome back. I hope you enjoyed your coffee break. We are back here for the next session, and our next speaker is Giorgios Kalantzis with a presentation to mock or not to mock. Please, a big round of applause from George.
Hello everyone, I'm Giorgos. I work as a software engineer, and whenever I sit down to write new tests, I run into the same questions. Should I mock here or not? And if I do, which kind of test double is the right fit? To answer that, let's start at the beginning. What exactly is a test double? Well, just like actors don't perform every dangerous scene by themselves and stunt doubles step in for them instead, okay, maybe that's not true for Tom Cruise. He does his own stunts usually. In the same way, we use test doubles in place of real objects. They take the risks for us, making our tests faster, safer, and more predictable. Without them, our tests get tied to real services and environments, and that's when things become slow and flaky. Having said that, let's take a look at the different types of test doubles. We have mocks, stubs, fakes, and spies. All of them can replace objects in our code, but each one serves a different purpose. And in fact, they can be used together as well. But what is a mock? A mock is a type of test double that stands in place for real objects in our code. It replaces the original object with one that we can control the behavior of, and allows us to track the interactions with the mocked object. In Python's built-in test framework, there are two foundational classes that create mocks, mock and magic mock. Now, let's have a look at some features of the mock class. We can call any method with any argument, and the method exists automatically, while the return value will be a new mock. If we call the same method again, we can assert all of them at once. Just be consistent in mixing arguments with keyword arguments in call assertions. You have to assert them the way they were called, in the exact order. What is the difference between the two, though? Magic mock supports magic methods. So, let's see an example. Suppose we want to use the object in a with block. In order to do that, our object needs to define the context manager protocol. This means it needs to define the enter and exit, at least, which are magic methods. However, mock objects do not do this automatically. As we can see in the right column, our snippet fails with a type error. We have to use a magic mock if we are going to call magic methods in the code we test. And this is not, of course, limited to with blocks. It might as well be other special methods like length. Should the object we are trying to test behave like a sequence, a list, or a tuple? But how to actually replace the real object with a test double? In the case of a function that owns the dependency, we need to use mock.patch and patch the imported name where the dependency is being used. For example, read file owns the file IO dependency, and it is responsible for opening and closing it before reading from the file. In the left column, we patch it, and by default, mock.patch replaces the object with a magic mock. But you can also provide your own mock object with a new argument. Note that patching globally at the place file IO is defined does not work. Why is that, though? Well, when we import file IO from the IO module, inside our example module, we bind the local reference to the name file IO. Secondly, our patch targets the global file IO name, but read file uses the local reference already, so it won't capture our patch. To fix that, we would have to do lazy importing, which would have called our patch before importing our example module. Or we could have to reload explicitly, both of them not a good practice usually. But there is a better way. In what other ways can we replace a dependency? In this example, we call read file. The implementation simply returns the contents of the already opened file. Notice that read file does not own the file IO object, it just operates on it. When a function accepts its dependency as a parameter, there is no need to patch. Instead, pass a mock object in place of the dependency. In the test, we create a magic mock with a spec argument. The spec makes the mock strictly follow the protocol of the file IO class. That's why calling an arbitrary method on it raises an attribute error. The mock only allows real file IO methods. If we can't inject, we patch, as we saw earlier. Besides decorators, we can use patch as a context manager. And patch object is also handy when the module is already imported and we patch its attributes directly. Just like the decorator lives for the duration of the wrapped function scope, the patch lives for the scope of the with block. We can use the autospec flag to have the mock automatically deduce which protocol to follow. As of now, we have covered mocks, but what is a stub? How does it differ? Well, stubs provide canned responses, helping us test outputs or control intermediate results. Mock and magic mock, the usual suspects, can be used to provide these results for functions that we expect to be called in our unit. In our example, this function is called some method. One way to set fixed responses is to set the return value. This way, every call will always return some value. In the case of repeated calls with different return values, we can provide an iterable to the side effect attribute. Finally, to test against errors, we can use side effect to raise exceptions like a value error. Let's see an example. We have an in-house authentication library with a function called authenticate. It goes off to some remote service and gives us back a token. It takes an account ID that's required and an optional resource ID. The idea is that sometimes we want a generic token for an account, but other times we need a token specific to a resource, like, let's say, storage service. Our utility function, getHeaders, takes this configuration, calls authlib.authenticate, and uses the return token to build a dictionary of HTTP headers. We include the token in the authorization header of our request along some static headers like content type. When testing getHeaders, we need to make sure to replace authenticate with a test double. What type of test double to use in this case? Let's look at the left column. We may be tempted to just stub authenticate by fixing its return value to a dummy token string. This test has full coverage and it passes. But if you recall authenticate's signature, in fact, we didn't actually propagate the resource ID that we got in the configuration object. Our unit test would still be successful, but we would totally miss the link between resource ID and the generated token. To fix that, we can use mocks to also assert the arguments of the call to authenticate. Now, if we forget to pass resource ID, the test will fail, alerting us to the bug. So we use mocks and stubs in synergy in this case. Do we have to always use stubs? And what is a fake? A fake is a working implementation of a real object, but simplified for testing. Unlike stubs, you don't have to predefine return values. The fake behaves like the real thing, just without the heavy parts. This means no network calls, no file I/O, and no external services, but still with realistic behavior. Let's see again an example. On the left, the real storage client. Let's suppose it follows the mapping protocol and behaves like a dictionary with getItem and setItem magic methods. It also supports the context manager protocol. As we saw, this means that it has enter and exit as well. And it talks to a real service with implementation methods provided by storage provider base class. On the right, the fake storage client just uses an in-memory dictionary instead of connecting to the real thing. This keeps implementation lightweight, avoids maintaining stub states, and makes tests faster and more reliable, while being close enough to production behavior. Let's suppose we need to build a more complex storage client with serialization and chunking due to some practical network restrictions. Let's also suppose we cannot modularize the code further. So we have the safe object function that takes a storage client, a key which will be the name of the object inside our storage, and the object which is the dictionary to be saved. Next, we serialize the dictionary to JSON format and we encode. Now we have the serialized data and we need to chunk them based on the chunk size parameter. We also keep track of the chunk's length to help us during reassembly. For the load object, we accept the storage client and the key of the object. We need to reverse the operation, so we first retrieve the number of chunks. Then we assemble the chunks in a bytes object. And finally, we decode the bytes and load the JSON string. But we also need to test this. Would stubbing be a good choice here? Well, stubbing can easily get complicated in this case. For example, we need to re-implement the chunking logic of the real solution to produce the intermediate stubs for the serialization and deserialization. What's more, we need complex logic for getting and setting the individual chunks and the chunk length. I have omitted them for brevity, but these would be several lines of implementation. And you can imagine how convoluted this can be, maintaining the stubs after a few iterations. If we need to add a new step or change the serialization step, for example, for a compression step, this would be complicated pretty quickly. A fake storage client comes to the rescue as it provides a drop-in lightweight replacement for the real storage client. And we don't even need to replace it via a patch since we use dependency injection. We just test the round trip. No need to maintain stub states. If we also want to track the calls to the fake getItem method, let's say to assert we retrieve the chunk length and didn't accidentally hard-code it inside the fake, we can wrap it with a magic mock. Now, what is a spy? A spy is a test double that wraps a real object instead of the fake object we saw previously. Unlike a stub or a mock, it still runs the real implementation, but we also get to track interactions. In Python unit test, we can create one with mock or magic mock again, using the wraps argument. Here's an example called $converter, which has some static exchange rates. when we call convert $10 to euro, the spy runs the real logic and returns 9, just as expected. At the same time, because it's also a mock, we can assert that the method was called once with the right arguments. Well, this brings us to the takeaways. So far we covered mock that verifies the behavior, stubs that control outputs, fakes that are working minimal replacements, and spies that wrap real code for inspection. A few more things to have in mind. Well, prefer magic mock over mock unless you are sure you don't need magic methods. Use autospec or spec to make the mock strictly follow the real objects protocol. Prefer dependency injection over patching when possible. Use patching when you interact with third-party code that is not modular and you can't inject the objects yourself. If you need to patch where the dependency is being used. And in unit test mock and magic mock can be used in a way that combines all types of test doubles to achieve completeness. Thank you very much. I hope you got something from this talk.
Yeah, thank you very much. A big round of applause for George. Thank you very much. We have time for a few questions. Are there any questions from the audience? Yes.
Is there one particular reason why you don't use PyTest instead of unit test, or just because you were more familiar with?
I'm more familiar with unit test because it's also in the standard distribution. You don't need to include the package, and most of the time I have used this in the companies I've worked for. I think the difference between the two is that unit test is more class-oriented. So you have the setup, teardown classes to control when you define the objects. The other one is more functional, but they support similar things.
Is there another question?
Thank you. I'm trying to find how to phrase this. Do you think it's important to know, as you start writing the tests, which kind of double you're going for, or is it okay to switch and see how it goes?
Yeah, good question. Well, you start from somewhere, and you can ship the code, and you can be pretty sure that does the stuff you want. But later on, you add the feature, you may want to change to a different test double. If you planned before, and you knew what kind of things your code would do, it would be beneficial, obviously, to pick the correct. But this is the thing that I'm trying to say, that there is no silver bullet. You have to think about what are you doing and how to guard yourself. Yes.
Is there another question from the audience? We still have time for more questions, if there are any. No questions at this time. So a big round of applause for George again. I'm sure he will be around. Thank you very much. We will now have a short break, and we are back in this room at 4:35 for the next talk. Thank you. Welcome back. We will continue with our schedule. Our next speaker is Stavros Niafas, and he will be talking about hot swapping MLflow models. A big round of applause for Stavros.
Okay, shall we start? Great. Thank you for being here on the almost last session of this PyCon. So yes, my name is Stavros. I'm an ML engineer. I'm working in SafeSize, and for this session, I'm also wearing the hat of MLflow ambassador. The material of this talk, source code, and also the slides will be on my GitHub after this session. So what are we going to see today? So this session is built up slide by slide. So we'll start with the motivation of this talk. We will see what's behind to keep our models fresh in real-time environments without downtime. So we'll see why inference in serverless. We'll give a round to learn what is the machine learning ML lifecycle and some things about MLflow, which is the main technology of the whole, let's say, architecture. We will see what is Amazon Lambda and how we will be using this. And of course, the main context of this session, the hot swapping, and the last round of a live demo. So let's go. Great. So what's behind the, let's say, updating models in production? So we know that no matter how well machine learning models are trained, over the time they can suffer from model drift and also data drift. And as new data are coming, we can encounter some changes in our, let's say, predictions or recommendations or whatever our models does. So it's very, let's say, crucial to adapt whatever changes are happening in real-time environments. So let's say when we update our models, this can cause a downtime in our application, and this is when we are interested in environments that are, let's say, sensitive, let's say time sensitive, where let's say downtime is crucial. So this, let's say, when we're going to apply dynamic updates, it also helps, let's say, to speed up the entire machine learning lifecycle. And also, it also helps us to, let's say, avoid of rebuild and restart the entire application. So what's behind the hot swapping idea? It's that we have an event, let's say, driven architecture. So our models are going to be updated when some kind of event happens. And we are going to replace the current model that there is in production with a newer model. So the way that we are going to do this is complete, let's say, Pythonic. I'm not going to tell you now, you might gonna guess it by now, but I will leave you with a cliffhanger. So about, let's say, machine learning inference. Anyone here who is not, let's say, familiar with what inference is? Okay, awesome. So Yeah, serverless can be, let's say, somehow, let's say it can be a confusing term, but there is still server, but we don't care about how is this managed. So we only, let's say, we are focused on how we implement this inference logic in production. And also another, let's say, advantage of it is that we have zero overhead. We don't need to, let's say, think about the API. We only, let's say, focus how our inference logic will look like. It integrates seamlessly. We don't need to do, let's say, something that, let's say, it concerns with the managed service or the API, as we said. So it also allows for faster, let's say, experimentation. We just commit, rebuild, and the Lambda, let's say, code automatically updates. The only thing that we should look at when we, let's say, work with Lambda is that we can, let's say, we should rebuild our Docker image, which hosts the main Lambda logic. And also we should look at the cold starts of the Lambda. We will see later what this means. So let's have a look on the machine learning lifecycle. Anyone here who is not familiar with what the ML lifecycle is? Awesome. So I think that I can skip that, but anyway, the main topic of it is that we use ML flow to, let's say, manage the entire life cycle from data logging, experiment and model logging up to, let's say, model deployment. So some sort of text about ML flow. Anyone that already uses ML flow? So no one uses ML flow. So you do the life cycle without ML flow. Okay, awesome. So, okay, ML flow is an open source platform able to assist machine learning professionals and teams to handle, let's say, complex or more simple machine learning applications. So ML flow focuses on the full life cycle and actually ensures that each phase is manageable, it's traceable, and can be reproducible. So we can implement the whole life cycle. We can have AI governance of our models and experiments of everything. And also it can help to bridge the gap between experimentation and production. And also it can reduce the friction between the teams, as the ownership always stays in the data science team. So if you don't use ML flow, you should definitely do it, even for your, let's say, pet projects. It offers a great documentation. It covers a handful of case studies. And of course, you can also come in touch with a community in Slack channel. So, yeah, I forgot that I have steps here. So anyway, let's go forward. So what about Amazon Lambdas? Anyone that uses Amazon Lambdas? Awesome, 1, 2, the lights, 3, 4, 5, okay, awesome. Okay, so Amazon Lambdas are dead simple, actually. you have only a, let's say, main function that actually plays a role of what is served. So this is the handler, and everything that is that is around the handler takes place of the entire execution environment. So when we spin up our lambdas for the first time, or even if the lambda is become cold after some period of time, the first thing that runs is everything that is outside the lambda. So for this case, let's say that we just load our models, and when the lambda is warm, everything that runs when we, let's say, execute an API call and ask for a result only happens in the invocation part. So the question is, how do we leverage the lambda with the Pythonic way in order to, let's say, update the model while it's still warm? So the difference with, let's say, a system that does not run in the lambda is, let's say, for example, an EC2 instance, is that when we have a new model, we should restart the whole service. So the catch here is, how do we still give, let's say, recommendations in our system, and we can also update the model without restart the whole service? Or alternatively, how do we still keep the lambda, let's say, warm? So, okay, hot swapping. We will have a quick look on the architecture behind this. So yes, so it's quite simple actually. When we train our models, we make sure that everything is run out there in an MLflow environment, and we track our models and experiments in the MLflow server. So we just run our models. MLflow offers a very fluent Python API with very little overhead, actually, almost to zero overhead. So when, let's say, that our training run time is completed, then we should serialize our models in an external, let's say, storage system. For this topic, we will use S3 buckets in Amazon. So the idea is that after we train, we use the MLflow client to take all the information of the MLflow server, and we serialize our models in a, let's say, dict-like structure, in a JSON-like structure, you name it. And after this, it means that we already have deployed our Lambda. So Lambda is already there, and when Lambda starts, it's going to load the serialized structure from S3 directly in its content. So Lambda will be up, and up to this point where our service is up, we're going to, let's say, experiment and see from our client here that, okay, we can get some results, and what happens next if we retrain the model and when we update again the file structure in S3. So yes, this is where all the magic happens, actually. This is the logic that exists inside the Lambda. So the refresh model function handles the loading of the models from S3. So we use a global variable, the model list, to store the loaded models in memory. So this will we will make sure that this variable will keep living for all the entire runtime of the Lambda. So this code, as we said before, is defined outside of the main function. And by the time it's up, it loads the serialized model from S3. So when we detect a newer model, we check, let's say, given a time scheduler that we have set it up, and let's say we are aligned in the team that we want to update our models per based time schedule. I mean, per hour, per, I don't know, 6 hours, whatever. For the sake of this demo, we will set it for 1 minute in order to have, let's say, fast updates. So the rest are, I think, are very simple. So we replace we also check if the version of the newer model is different, and then we replace the model. So I think that it's time for a live demo. Okay, I will need my both hands. Okay, and also I need to turn my head. So okay, this is the training script. We will use just for this demo a very simple data set of the iris data set. And we are going to train a linear regression. So let's say that the task here is just a linear recommendation of what the flower is. So yes, let's give it a spin. So awesome, our model is trained. It is logged in our central, let's say, management system. So let's move forward to the serialization logic. So what happens when we serialize the model? Give me a sec. Okay. So this is the main point that we use the MLflow client, as I said before, to fetch all the information from the central MLflow server. So in this case, our model is named Iris model. So we go through all the models, all the register models, and we take the version, the model name version, and anything that is related with our task. So this is the part that we actually serialize the model in a dict-like structure. And the logic here is how we leverage Boto 3 in order to register or upload or write or whatever this structure in an S3 bucket. So it's very simple. We have our function here. It's just how we open a session to S3 bucket and actually register our artifact. So let's move on how the lambda looks like. As I said before, all the logic that lives outside the main function is related to load the, let's say, artifacts. And this is where the magic happens, where we refresh the model. We set the 1 minute time schedule. We read the model from the structure, and this is the handler that actually gets the model and does a prediction. So, moving forward, we will, let's say, start our client that sends a request every 1 second. Okay, our lambda is up. We get, let's say, the recommendations. Our current model version is 4. If you remember, we already trained the model. It went on the next version, model 5. Now we are gonna do the registration or the serialization. And up to this point, we're rewriting the structure on the S3 bucket. So it's uploaded, and we have to see in like a minute how much time we need. 40 seconds. Yes. So in 40 seconds, we should be able to see the model version to be, let's say, proceeded in version 5. So remember, at this point, Lambda is still running. We are not doing anything with the service in Amazon. And when the time schedule, let's say, is enabled, at this point, we should be able to see the next model version. Okay, happened. Awesome. Great. So, yes, that was it. Thank you so much.
Thank you very much.
Thank you.
We have time for a few questions, if there are any questions from the audience. Yes.
Hello.
Hi.
Thank you very much for this interesting presentation.
Thank you so much.
My name is Alex, and I want to ask you, how do you tackle Lambda memory restrictions? Because as far as I can understand, when you are doing the swapping, both serialized models are on memory, and the ephemeral storage in Lambdas are limited. So how can something like that serve production models, let's say?
Yeah, that is actually a good question. As I said here, let's say I would use this Amazon Lambda, let's say, structure for more, let's say, simple kind of models. Let's say for applications that are lightweight. I would not use this, let's say, architecture for a CNN model or for a model that, let's say, takes images, that, let's say, reads images, or it can have eventually GPU. So I would say that for simple applications, you will not have an issue.
Okay, thank you very much. I have tried a lot about this, so I'm asking because if you had any good idea that
no,
I didn't know.
I mean, up to this point, we have like 6 months of, let's say, running Lambdas, no issues yet.
Oh, great. Thank you very much.
Thank you.
Is there another question? Yes.
Alex, I was just going to say use ECS. Like this is just a general technique. It really doesn't matter if it's a Lambda, it's ECS or anything else. If you need more, use a different service.
Thank you. Is there another question from the audience? Yes.
Thank you very much, Stavros. So, to make things clear, you're trying to ensure that a cold start will actually, if you could enforce a cold start, the output would be the same, right?
Right.
So you need to refresh your memory somehow, and that's why you're keeping track of which is the latest model in your S3 bucket.
Right. Actually, as we use it, let's say in our systems, is that we make sure that Lambda does not get cold for the time that we need to, let's say, have recommendations to the customer. So we have, let's say, a dedicated period of time that we say that the Lambda should be on all the time. So this might be, let's say, have some trade-offs. Let's say if our service lives in worldwide, and not in a, let's say, in a specific region. But yeah, up to now, this is the way that we are doing it.
No, it's very, very interesting.
Yeah.
Nice idea. Thank you.
We have time for another question, if there is any from the audience. Yes.
Okay, hello. Thank you very much for the presentation. So I was wondering about what you just said. Then why don't you have like an EC2 just running and turn it off when you want the period?
That is because, let's say, our application is time sensitive. We don't want it to get down, even if we upload or refresh a model during the day. And because our service is totally worldwide distributed from US to Japan, we need something that it's already up. Yeah.
Thank you.
So this goes up to how we are gonna, let's say, use it. If our system does not allow, or let's say allows for this kind, let's say, of architectures, we of course can do it.
Good. Thank you very much.
Is there another question from the audience? We might have time for a question if it's a quick one. Otherwise, thank you again, Stavros. A big round of applause for Stavros. We will have a short break now, 5 minutes, and stretch your legs. We're back in this room for the final keynote and the closing remarks of conference. Thank you.
Testing, testing, 1, 2, 3.
Are we good to go? Great. Okay, welcome back everyone. I hope you had a good day. I know you're all sad because this is slowly coming to an end, but there's still one amazing talk to hear. And it's my absolute privilege to introduce a friend now. And yeah, I mean, what can I say about this person? He's one of the people that has probably helped me the most in my Python journey. And when he said yes, I was so happy. It's really amazing that he's here. He's done a lot of stuff. I'll try to mention some of it. He's on the steering council, the Python steering council. He is the release manager for 3.10 and 3.11, and he's a C Python core developer. And everything he does well. And he's probably one of the smartest people to walk into any room. So I'm so excited for you to hear this talk. He doesn't do one thing well, which is apparently to play feuding Pythonistas. So yeah, you could have been a bit better. Yeah, please give a really, really warm welcome to Pablo Galindo Salgado.
All right. So let me start with the elephant in the room. So this is as you will see in the rest of the slides, I like to put like a nice theme on my slides so they are kind of beautiful. I spend a stupid amount of time. But the first slide is always the corporate thing, right? And I have like the corporate slide already done, but like my company was like, no, you need to change the slide. And I was like, why? It's like, because do you see that copyright notice here that nobody can read? It says 2022 before, you need to say 2025. Like, okay, I will change it. And they provide me this slide with the date wrong, because it's like, it says September. You see, well, not my fault. All right. So cool. So keynotes are a bit different, right? Because like you need to basically withstand me for 45 minutes, which is a lot. Like I speak quite fast, and I know it can be quite intense. So keynotes normally cannot be super technical because like people cannot like hear you talking about technical stuff for 45 minutes. So I was thinking always in my keynotes like, how can I make the time of the people that are hearing me the best? Like what can I teach you that you're going to find it more useful? So what you're going to hear is basically like my own perspective of like something that I think a lot of people secretly struggle with, and like this is not something that we talk a lot, which is like career paths, and like what do you do with your life? In particular, you spend a lot of your life like doing your work, right? And like in particular, you're doing Python, but you're using Python for something else. And like that is a surprisingly complicated topic, and like how you approach career and like how you approach decisions and things like that. So I try to condense basically in this talk like as much as I could of how I approach this and like the lessons that I had and like what things I think are more important. So maybe it teaches you something or like changes a bit your perspective. But first, I'm going to start with something interesting. So what you're going to hear right now is one of the most interesting conclusions of this talk, which you're not going to understand anything at this point, but you will understand at the end. And hopefully, you will only be able to understand this thing once you listen to the entire talk. But let's listen to this. So this is an interesting sound. For now, I just want you to listen for like 20 seconds and like start maybe guessing what this is, like where this is coming from. Sounds surprisingly musical, but like maybe a bit like like monotonic. So something is going on. Mysterious. So let's continue and see what's going on. Okay, cool. So I'm Pablo Galindo. I like to present myself like my code runs on your computer. Which sounds a bit threatening, but that is true. This is and this introduced me to quite an interesting thing, because a lot of people, when they hear core developer and whatnot, but like they don't know exactly what it is and like what is the responsibility. So I guess I wanted to start here and talking about like Python, which is like quite wild when you think about it. And in particular, I'm not a serious person. You can see here the steering council like panel of this year. This is like a very serious meeting in front of like almost 2,000 people. And here you can see me with these stupid ears, just because someone told me that if I humiliate myself with these ears, they will donate to the PyLadies, so women around the world can like learn more Python. So I say yes, of course, because like I'm not a serious person. And this is one of the things I want to try to convince you here. Like people think about core developers and like like the people that are doing the language, like these secret people in suits that go to these rooms and say, oh yeah, let's put an if here, yeah, a for loop, oh yeah. And no, we are just clowns. And this is what I'm trying to convince you as well. Like, you can also be a clown. Amazing. So one of the hardest things and most scary things that you need to do when you're a core developer is deal with this button over here. It's a very scary button, because when you press this button, like everything changes. And I wanted to show you about like, this is a bit of an exaggeration, just because like we are not thinking about this all the time. But I wanted to show you just a sneak peek of like how much pressing this button can change when you are in charge of the biggest programming language. And this is because like Python is quite a big language these days. Like if you go to one of these like arbitrary indexes of popularity, you will see, in particular the TOB index, that Python has been the first one for years. Not only that, like this thing is even growing more. Like right now, this is the last result as of last week, and this is like growing 10% like from the previous version. Like this is leaving all the other languages like super behind. And this also shows you like an interesting picture, because like if you think about Rust, which is like a lot of people talk about Rust like being super popular, right? Rust is not even in the top 10, right? You can see Java, which is like, that opens a bunch of questions, but like, let's not answer those questions here. And Visual Basic, Jesus Christ, I have not Visual, like, wow, that's dangerous. Okay, cool. But Python is quite popular, right? And it runs almost everywhere. And it keeps running more and more and more because like right now with all the AI stuff, it tends to be quite important. So I asked myself the following questions. So given like how much this is growing and how much this is being used, what happens if I press that button and something changes? In particular, let's say I'm going to, let's do like an experiment. What happens if you press the button and you make Python 50% faster? Like what will happen? Well, if you make Python 50% faster, basically you can ask the following questions, like if Python is more efficient, then it will require less energy, and that will basically translate to less amount of CO2 released to the atmosphere. What is that number? Well, that number tends to be basically 15 millions of metric tons of CO2. Which is a lot. The number basically was calculating using a bunch of like papers, like estimating how much like developers are worthwhile, how much of those is using Python. So I spent like 3 or 4 hours basically chasing this thing, looking at like estimates of how like these big companies using Python and how much that they spend. And also another thing that you need to think about when you think about this number is that improving Python can have a big impact. Particularly, for instance, because it's 75 times more energy inefficient than C. If you will make the C language like 50% faster, because C is already super efficient, that will translate to almost nothing, because like this is already not consuming a lot. But because Python is very inefficient, like making it 50% faster is like having a lot of impact, right? And if you go and like go through the numbers and basically calculate this like very abstract thing, you will arrive to the basically number that I gave you, which humans are really bad on numbers. So let me give you some translations of the number. That number is equivalent to basically planting 500 million trees, or remove 2 to 3 million cars, or basically eliminate all CO2 emissions for entire countries like Lithuania and Slovenia, which sounds very impressive. But then when you look at like how much this is of the total CO2 emissions in a year, this is just 0.02%. Turns out that cows are very bad at this. They have methane and a bunch of stuff, and like planes and whatnot. So still not making a ridiculous impact, but like I was thinking like even just like think about how easy is the action to press the merge button, right? And like suddenly you move this number. It's quite ridiculous when you think about it. Obviously, this can translate as well in the opposite direction, right? Like maybe you merge a PR that looks okay, but then for whatever reason you don't notice that it makes Python like let's say 2% slower than some mega benchmark or like some AI stuff, and now you are releasing more CO2 to the atmosphere. I can promise you that no developer thinks in those terms, so we are not like looking at the merge button. It's like, how many CO2 tons of CO2 I'm going to release with this day? But it's quite wild when you think in these terms, because like it shows you like how much impact can you have when you have like such a big responsibility in your hands. Cool, but that's Python stuff. So a question that a lot of people ask me about is like, how did I arrive to do Python? Because I'm not a computer scientist. I am an imposter. I'm a physicist. I'm just like here trying to be cool, but I'm not one of the cool guys. When I was studying physics, I was really studying, and I met Python for the first time. I studied physics, my PhD, and my PhD is about black holes. And I was basically dealing with these disgusting equations, really complicated stuff. And these are equations tend to be so complicated. These are the questions that basically describe how light moves around black holes and whatnot. And these equations are so complicated that like you cannot just solve them. So you need to throw some computers at the problem. And obviously those simulations were not done in Python. Those simulations were done in CUDA before CUDA was a thing. Well, obviously not a thing, but like before it was popular, before all the ML people started to talk tensors and things like that. Yeah. But these are tensors, by the way. These are real tensors. You see, they look scary because they are scary. Yeah. But the thing is that like I had to use Python a lot to basically move data around, and basically the same reason Python is used these days. And the cool thing is that when you do these things and like you simulate these things, you can produce very cool images like this one. So for instance, this is one of the images that I was creating in my PhD. Now these are super popular since the movie Interstellar. But what you are seeing here is a rotating black hole. Like the shadows are a rotating black hole. That's the black part over there. And what you're seeing here is one of the most cool parts of general relativity. This ring that you can see around is not really a ring. It's a single star that is behind the black hole. And because the black hole is deviating light all around itself, it's like bending the light in all directions, that single star that sits behind the black hole emits light that curves in all possible directions, and you see it as a ring. This is so cool and so amazing that this is used as a test of general relativity plenty of times. If you Google Einstein cross, you will see one of the most famous cases of this effect when like you have a black hole which is big enough, and then you have like an entire galaxy behind behind it, and you see 4 copies of the galaxy, because like there is dust and whatnot that doesn't allow you to have a perfect ring, but you will see like 4 copies of the galaxy in like all the cardinal points they are really just one galaxy. And it's very cool, because if you point your telescope to every of the copies, you will see that they emit exactly the same light. That's how we know it's the same galaxy and not 4 of them. And this is, like knowing how this distorts space-time, we can calculate how big is the black hole, which is quite cool. And like one of the things that my thesis was about is like give enough mathematics to make this kind of thing more efficient. And obviously you don't see these things this way. You normally will see in the movie Interstellar like something that looks like this, which now you have like plasma, like, you know, circling about the black hole and falling into. And what you can see here, like all these like weird like rings, is basically the ring being distorted by the black hole. If you right now doing the following thing that I'm going to show you is very easy, because like computers are fast this day. But when I was doing my PhD, the movie that I'm going to show you took like 3 weeks to render. Something that you can do here is like take some nice photos, or even a video. Hopefully you can see it here, and you can see here a video of like a camera going around the black hole, and like you can see a bunch of cool effects. Particularly, you can see 2 rings over there, but technically it's just 1 ring. And what happens is that the inner ring is just light that is being bended by the black hole a bunch of times and being emitted in the center. There is no second ring. It's just like a shadow of the first one. And as it turns, you can see actually how the inner ring is bending to be the outer one. You see it there? Bonk. Like, look at the inner one, and then when it turns, it becomes the outer one. And that is because the light is being distorted around. This is very cool. But you can say, hey, Pablo, like, this is actually much cooler than all those like CO2, like Python stuff. Why did you stop doing this? This is quite cool. Well, the reason is because like, one of the things that I was super excited about is that you can actually use this thing for something pragmatic, right? And one of the things that you will see if you study, like for instance, the center of the galaxy, and then you look with your telescope at all the different stars that are in the center of the galaxy, is that they are doing something very weird. For instance, this is a movie of like several years of observation, and you can see that all these stars are orbiting something, but there is no star in the middle. There is just black. So if you actually chart this, you will see that basically all these paths are orbiting something over there, but there is nothing over there. And then you can see, wow, maybe that is a black hole. And like maybe observing how these like stars are like moving around, you can infer things about the black hole. But this is the important thing. You don't know what it is, because this is science. You cannot just say, oh yeah, maybe it's a black hole, and like if it's a black hole, it's this big, right? You need to actually prove it. And to prove it, you need to actually look at it, like we did several years ago, and produce like nice images. But you need to have like some other image that is simulated that you can compare this image to and say, okay, if it's a black hole, it should look like this, or like I will compare this. And this is something that I wanted to do a lot, and this is what was driving me at the time, and this was my objective. And as you can see, that was a big thing some years ago. But it turns out that science is kind of sad. Because science is not all about like those things, and there are things that are super cool indeed. Like for instance, this is one of the results I'm more proud about. This equation over here, which you don't need to understand, you don't need to be scared about, but this equation here tells you what is the maximum time that it takes for a ray of light to fall into a black hole. And as you can see, the math is quite complicated, but the answer is quite simple. It's 2 pi times the mass of the black hole. So if you normalize by the mass of the black hole, the answer is 2 pi. And because there is nothing specific about your election of things in this formula is universal. It means that it doesn't depend on anything other than nature itself, which means that you can use this as a definition of pi. This is an alternate, like this is a valid alternative definition of the number pi. It's like literally half the time, the maximum time it takes to fall into a black hole, which is kind of crazy. So next time someone asks you like what pi means, you can just drop this thing and like impress them quite a lot. Maybe Hugo could use this information to put it in the release notes of Python. Like quite cool. Cool, but science is not all about like these things, and this is precisely what I changed, because it turns out that like science is quietly like sad in my opinion. The reason is because most of the time you're not actually doing science. You're actually like trying to convince boring people in the government to give you money to do science, and like those people don't care about anything that you do. They just care about fancy words and whatnot. And like not only I was spending more time doing this, but like after years and years of like trying to do academic excellence and whatnot, my salary was really super sad. I was earning like 700 euros or 800 euros a month, and my rent was like 600, so it's ridiculous. So I had to basically make a very hard decision to move from science to the industry, right? That's when I said, well, maybe doing this Python thing is going to be something. But like this is a big problem, right? Like when you are doing something that basically is your passion, and for me, science was my passion, right? And then you, for whatever reason, you need to move, either because you're forced to, or because you find out that like you cannot do it anymore, or because something else in life, something very deep inside you breaks. because like the reason you do things despite your salary, despite the fact that like you need to deal with this like paperwork all the time, is because this is something that you love. And when you need to abandon something you love, it's not only sad, it's like breaking, like something in your very soul breaks. And this is something that happened to me, but I have to change because I knew that I was not going to be happy doing science. So I started to study computer science because, like, I have just knowledge of Python, but I have no idea of anything else. I have no idea of databases and like algorithms and whatnot. So for 6 months, I went to the same cafeteria and I studied all computer science. Amazing. And then one of my friends went from the institute that I was working on and went to work to Google. And they said, oh man, like you should work here. Like they have free lunch. I was like, wow, free lunch. That is what I want to do. I will abandon science for free lunch. So I put an objective, and my objective was I must go to Google. Like, that's what I must do. So I did that, and I applied to Google, and I passed all the interviews, so they fly me to impress me into the London offices, and I did the on-site interview. And all of them went really well until something happened. This guy went into the room and showed me this thing and said, this is a grammar of a language. Does anyone recognize the language, by the way? This is Perl. So he wrote this thing on a whiteboard, and said, like, create a parser that parses this language. And, I was this tiny person, like 22 years old or whatever, like scared of like Google and the free lunch, very impressive. So I was very impressed about all those free lunch, and I was like, here. And I knew how to do like a bit of parsing. I have done some exercise on like parsing a bunch of numbers and a calculator, so this was clearly out of my league. And I did the best. And actually, I created a parser that indeed was parsing this language, except that the parser was disgusting, right? Because like I didn't know about parse theory and whatnot. So I failed the interview and I never went to Google. But like then, like remember this because it's going to be important in a second. But like then I applied to Bloomberg when they don't have bullshit interviews. So I actually, passed, and now I've been working there since then. And that is a very interesting like first lesson. Like having like being laser focused on achieving something, which is like what people tell you should do about like be laser focused on like your objective and don't let it go. Like that can lead to like a lot of frustration and a lot of like problems along the way. And you will see that there is some interesting aspect of this. So sad. Pablo didn't went to Google, but Pablo ended in Bloomberg. Much better. I don't have free lunch, but I have a lot of friends. That's actually better. Cool. So again, like this is showing you like expectations can be like a bit complicated, and especially when like you have something that you really want to achieve, and like for whatever reason you need to abandon or switch directions. Being too rigid is kind of a problem. So let's go to this thing. So this thing is something that I have tattooed in my arm. It's in my right arm. And the reason is because when I switched to Bloomberg and I was already accepted and it was a reality, it's like now you're going to be a software engineer with maybe free lunch someday. But like I was still sad because I was like, man, like I really feel like I'm a scientist and I kind of lost it. So I was really afraid to lose contact to the person I was, right? Like the person who loved science and the person who loved all these things. So I thought about the hardest equation I could write that required literally every single thing I learned during these 8 years of my life, which is this one. This is Hamilton equations in symplectic form, which sounds very impressive, but it's also like very nice and it has a lot of Greek letters. Amazing. Even this iota, which people think is a weird I, but it's, you of course know what it is. So yes, that's the advantage to talk to Greek people. People of culture, right? All right, so I tattoo this like when you go to a mountain and maybe you don't go to the highest part of the mountain, but you go to some respectable part of the mountain and then you plant your flag and say, this is how, like the farthest point I arrive. And I plant my flag and I will go down. I didn't arrive to the top of the mountain, but this is good enough and this is my flag and this is my equation. So, I put it here so I didn't forget where I came from. But since then, things have changed a lot because now I'm doing Python. And in particular, a big project that I did with a bunch of people is dedicating my life to parsers and symbols. So I'm going to talk about this. So this gentleman over here is Gukesh Langa. So Gukesh Langa is one of my friends from Python, and he's also the creator of a formatter that you may know about. It's Black, the Black formatter. Who knows about the Black formatter? Very cool. So let me tell you about the story that happened when I met Gukesh Langa. So we met together, and Gukesh told me about this tiny problem. So let's say you are importing a module in Python. You will use this syntax, and that's kind of cool. But then sometimes that can happen is that you can actually name the module. This is a bit stupid because I'm using food twice, but like you can give a different name if you review your slides. But and this line gets a bit bigger. Obviously, you can also change the name, and if you use a longer name, it becomes even bigger. and you can import several things, and then you can name those things, and now the line is so stupidly big that it doesn't fit into one line. So something that the black formatter will do, or you can do, is to use the power of the syntax of Python and put this thing on different lines. Wow, amazing. And this is so amazing because now you can have these trailing commas, which are really cool. These commas over here will save you in code reviews, because now if you modify the line, it only will show you lines modified that are the one that you change instead of the whole thing. That is pretty cool. And it turns out that something very important in language design is called internal consistency, especially in the grammar. And the idea of internal consistency is that if you have n things, you have n times n minus 1 over 2 possible combinations of those things. So those things grow very quickly. They grow quadratically. And the idea here is that a language is really good if you learn a pattern, for instance, that you can do this operation in which you can split the operation in several lines. If you can repeat that pattern with other patterns, then it's much easier for you to understand the language. Indeed, in Python, you can do literally this thing, for instance, when you import stuff in Python, but you can also do this thing when you define things in lists, right? Like you have a list that is very long, you don't need to do it in one single line, you can do it in several lines, and you can do these things, you say, well, the square bracket is the creator of lists. What happens if I change to the creator of dictionaries? You can also do this thing, like it works, you can split it in multiple lines. If you have a tuple, it also works. Instead of a tuple, you have a function call, it also works. It's literally, as you can see, the same structure. If you have now a function definition, it's exactly the same thing. And if you have, like, again, like an import, it's exactly the same thing. Or if you have a with statement, it's exactly the same thing, right? Oh no, except that it doesn't work for with statements. That makes you sad. And actually, now you can know why one of the bigger problems of Black, because Black likes to format the thing this way, and a lot of people were complaining about the sad face of Black. And the sad face of Black is like that it creates this like little parenthesis colon at the end, which looks like a sad face. And a lot of people hated it at the time, but now people don't care. And this was the problem that Lucas Lange told me about, that this trick of splitting things in multiple lines and using parentheses around works with everything except with statements. And Black also wants to format your with statements as well and put them in multiple lines instead of having the ugly continuation bullshit that everybody hates. And that was not possible because the Python parser didn't allow it. So at the time, I read a lot of books about like parsers. All these books here, they are super, super interesting. And I found like one of the passions that I discovered doing this journey is like parsers. I really like these things. So I read all these things, and I talked with Guido for the first time in the Cordova sprint of Meta in some year that I don't want to remember because it will make me feel very old. And we started to, think about the idea of changing the Python parser. And the Python parser is something very complicated to change because it was added at the first commit of CPython in December of 1991, which is the year I was born, which is kind of crazy. So it was a big complication. And it turns out that changing a parser is not easy. For instance, this is a bunch of code. Who thinks this code is Python? It looks like C++ almost, right? Well, this is actually Python. This is the AST of that code. This is just to show you that like what you think is Python and super readable and super friendly is just something that you think. Like Python allows some disgusting things. And this is because like what makes Python readable is your version of the code and how you write code, not what the language allows. The language allows a lot of atrocities. And in particular, like you will find that it's important to understand like how do you define what a language is. And for Python, we have this thing in the grammar. So the grammar is basically a file when we have a bunch of rules, and rules have names and descriptions, and this will look, you will see that they will look very much like regular expressions. So for instance, a rule can have several descriptions, several options in the descriptions, and this is important because you will see why this, like the context manager was not possible. So basically, you go to this file, you will find that you can write a rule name as several possibilities. We use this pipe operator to say this or that, it's like the or, and then every rule can be like regular expressions. For instance, this rule name is uppercase A, like 1 or more times, but you can have something like this uppercase A 0 or more times, almost like regular expressions. You can also have the square brackets to say optionally this other part, so you can say this rule is either the letter A or optionally this other thing. And then you can start composing these things for having something like more complicated. For instance, this grammar over here describes like a simple mathematical operations with a calculator. If you go to the actual Python grammar, you will start seeing things like file input, which is like a Python file. And you will see, oh, a Python file, what is that? So you start like going into the different names. For instance, you see, oh, a Python file is a 0 or more statements. What is a statement? Okay, a statement is a simple statement or a compound statement. Okay, what is a simple statement? And then you go down and down, and then you can see things that now they're a bit more familiar. For instance, you can see that compound statement is either an if, or a while, or a for, or a try. So you can see here all the things that are possible. And if you go to those things, you will start seeing things like those things. Like for instance, the yellow parts are like literally, they're called terminals because that doesn't expand anymore. For instance, if you go to if statement starts with if. Like you don't need to expand if anymore. If is the word if. So if you find if, then that's good. And then you go to name expression test, and then you need to find what that is and continue going forward. So this is what is a grammar. So it turns out that, like these terminals and non-terminals are quite important, because if you go to the while statements, you will see that after the while, there is this name expression test, so you will need to go into that other rule to know what's happening. And this go into the other rule can become very complicated in a second. So it turns out that we designed Python grammar to be an LL1 grammar, which sounds very technical, but it's very easy. This just means that you need to read the grammar from left to right, as opposed to the other way around, because that's a stupid choice that people could do. But most people shouldn't do this because it's harder. And the one means that if you are in a particular symbol, and then you have several possibilities, like this could be an if statement, or a for statement, or a while statement, and you need to know which one of them to follow, you can only look one token ahead. Like you could technically look 6 tokens ahead, like 6 words ahead, but in an LL1 grammar, the parser will only allow you to look at the next token, which is a very simple thing, but turns out that if you do that choice, then making the parser is a bit easier, and that's what we do design. Not only because the parser was a bit easier, because it makes the grammar much more simple, and that is what keeps Python, or at the time, that's what kept Python really, really simple and not super complicated, and that is what translates as you thinking that Python is very readable, with at the end is a very, very technical description. So for instance, this is the Python grammar, and you will see like a bunch of those terminals and non-terminals. And one thing that you may be interested on is saying, well, if I'm only allowed to look at one token ahead, and I have 3 possibilities, imagine if, for, and while, and I have the token raise, well, I know that I cannot go anywhere, right? Because I can only go to for, and for starts with the token for. I can only go to if, and that starts with if, and I can only go to while, and that starts with while, and those are my 3 options. So if I have something else, like raise, then I know that the program is invalid. So that kind of like all the tokens that you can parse, they are called the first sets. And these are the first sets of different things in the grammar. For instance, you can see that obviously the print statement can only start with print, but something like a simple statement, which is any statement, can start with assert, or del, or exec, or like blah, blah, blah. So the parser uses these tokens to know which one to follow. And this is the problem. The problem is like for something like the will statements, let me show you directly here. The problem is that if you want to write this thing over here, when you see the open parentheses, that is a problem because the parser doesn't know if that open parenthesis is a parenthesis because you are grouping the with statements, like this case over here, or because you are going to write a tuple. Like it doesn't know which one of the 2. So this is what is called an ambiguity. Like the parser has 2 possible paths, and it doesn't know what to follow. And this is very important, and you need to remember. This is because another one parser, which is a very classic parser, it has only one possibility to go ahead. It needs to know. It cannot try the parentheses and then like try the next tuple. It cannot like, okay, let me see if I can do it this way, or it cannot even receive an instruction from you and say, if you are in this ambiguity, do this. Like, it's a mathematical construct that is very rigid. It will follow only one possibility, and if it cannot follow the possibility, then it will fail. And this is the reason with the old parser, we couldn't have this nice with statement. It was just mathematically impossible. So something that the other problems that the parser had is that even if you think that the parser was very simple, writing some rules was not. This rule that you can see here is basically the grammar definition for function parameters. Not the functions themselves, just function parameters. This is very hellish. If you ever need to modify this rule, you will find that you will spend hours looking at this and you will hate your life or your decisions. So even like if people say, well, elegant grammars are super simple and they're super easy and like, very easy to follow, like it turns out that for real languages like Python, they start to like require all this madness, which is not fantastic. So something that we did with Lisandros here and Guido is that we decided to change Python parser. We decided to remove the parser that was served for almost 30 years and change it for a new thing. So we created a new PEP that changes the LL1 parser for a new parser, which is what's called a PEP parser. And you can see here the commits when the first LL1 parser was introduced. That was introduced for the first time in the first commit of CPython in 1990. And the PEP parser was introduced in 2020, so almost 30 years, which is ridiculous. So after this PEP, Python gained one of the most powerful parsers that you can throw in a language, which will allow, as you will see, not only like much better error messages, but super advanced constructs like pattern matching and a lot of the new grammars that we have, which impact millions of developers. But working on this, I met Lisandros, and I gained a friend, and I think I was the one who won the most. So here's an image of Lisandro and myself in PyCon. Awesome. So let's go back to this, right? So think about this guy. This guy failed me because I couldn't write a parser. But I know for a fact that the guy who failed me is writing Python these days. So this guy is using my parser now. So you see, you just need to wait a bunch of time, and the universe will have something to teach everyone. Cool. And this is the interesting thing. The PEG parsers are a bit complicated, so it's a bit complex to explain everything. But the interesting part, which will connect to how what I want to teach you, is that the whole idea of PEG parsers is that instead of using these super rigid mathematical constructs when they will do one thing and one thing only, and if you don't do the way they like, they will fail, a PEG parser, when you have a rule that has several possibilities, it will basically go one rule at a time trying to parse. And if rule A doesn't work, it will try rule B. And if rule B doesn't work, it will try the next one until one of them works or none of them works. If none of them works, it will tell you that your program is invalid. But if one of them works, it will just use the first one that happens to work. And very simple. Obviously, this is very simple to explain, and this is actually the whole idea of PEG parsers. You can explain it just with this. But obviously, as you can imagine, this process is very inefficient. So there is a lot of complicated machinery to make this still run in linear time. But conceptually speaking, that's the big difference. The big difference is instead of using the power of math and deducing what of the rules is the one that you need to follow, you just go and try the first thing that works. And if it works, then you're happy. And that's the whole idea. Obviously, there is a more complicated thing. So you go to the actual parsers, you will find that this is not an easy thing. And parsers one consequence of these parsers is that they don't have a concept of failure, because they are basically trying things until one works. So failing to parse a rule doesn't mean that the program is bad. It means that you need to try something else, which is very interesting, right? Failure is not failure. It means just try something else. It sounds like life advice, right? Suspicious. And basically, they are also super easy to write. For instance, if you have three options in your grammar, you just need to write 3 if statements. This is literally how you make a rule parsing in a PEG parser. Obviously, the real one is a bit more complicated because it's also made in C, the illegal language. A lot of people ask me why I say C, the illegal language. This is because some years ago, the White House said that C, writing C was super insecure, and that was made illegal. So that was very amusing because people still obviously write C. So I started to call C the illegal language because it's officially illegal. So but CPython is quite illegal. That's the C of CPython. Cool. So PEG parsers are cool, but one of the problems is that they are too powerful. In particular, if you say, well, if there were an LL something parser, what will be the something? Is 1? Is 20? Well, it turns out it's infinite, which is amazing, very powerful, but sometimes it's not that cool. For instance, one of the problems that happened, and this is a real problem that we have to deal with, is that someone went and say, hey, if I try to parse this code, which is incorrect, right? Because it's a bunch of open parentheses and they don't even close and there is a colon. This is just illegal. So Python takes 2 seconds to tell me that this is illegal. And I was like, well, it's not too bad. It's so it's okay, no? They say, yes, but if I use this, now it takes an hour. Okay, person that likes to write illegal Python, let me fix this for you. So the problem of these parsers is that if you mess the machinery that makes them not inefficient, then you can have this problem. This was a real bug that we fixed. Here is the bug, right? As you can see, avoid protection, exponential backtracking. And you can see that this bug was aborted by a person. So someone somewhere now is much happier because he can receive the illegal syntax error in less than a microsecond. Amazing. And thanks to Lisandro, as you can see Liz here, obviously helping make the world a better place. So it's very cool, but when you are dealing with super powerful machinery, sometimes you need to deal with very complicated errors, right? But something that this parser allows now is to have things like the match statement in Python, which is something super powerful, but it was only possible because of the PEG parser. Writing this, and every single other person that was parsing Python code had problems parsing this with inferior parsers, just because it's very complicated to parse, just because you need to know if match is a name or a keyword and is used contextually. Something else that we did now that we have the PEG parser that you may have seen is that we are now in a battle to improve all the error messages on Python. So I'm going to show you some of them that we made with the new parser. So something that now the parser does is that it knows when you're missing the colon, or sometimes, for instance, if you're missing, you have a dictionary but you forget an entry, now it tells you that it was missing an expression. For instance, if you miss a comma, this is one of everyone's favorites, it will tell you that maybe you are forgetting a comma. Wow, amazing. If, for instance, you never close a parenthesis, now it will tell you that a parenthesis was closed. close, which you will say, well, that doesn't sound too complicated. Oh, man. Like the error before was something called invalid, EOF found and end of, EOF found or something like that, right? EOF stands for end of file. And like, I like to think about when they announced that Python was going to be the official language to teach people in France. And I cannot stop but to think of all these like 8-year-old people thinking like, what is EOF? Oh la la, like. so yes, now it tells you that it's not close. Something that I did with Lisandros. So Lisandros was a 15-year-old when I started to mentor him, continue to see Python, and like, he's super smart. Now he's a millionaire doing AI stuff in San Francisco, amazing. It's not just thanks for my teachings, it's just because he's very smart. But something that we work together is to push more these like error messages. And something cool that we did back in Python 3.12, I think, is that if you have like, for instance, this traceback that is basically telling you that you receive a JSON or something like that, and then you're accessing a bunch of JSON keys. For instance, you're accessing A, B, C, and user, and the error is saying that, oh, some of those are none, because like non-object is not subscriptable. But then if you look at this thing, you say, but which one? And the only way to know is to attach a debugger and like just check which one it is. But after the changes that we did together, now the traceback looks like this, and it will point you to the one that is none. And now you will know. And you will see also that like it will highlight all the parts of the code that are actually failing. So if you have several parts in the same formula or in the same line, it will tell you what part of the line is bad, which is amazing because now you don't need to touch a debugger. I mean, you still need to solve it, which is the hard thing. But obviously, like, at least you don't need to touch entire debugger and lose like an hour there if you are like, just something is breaking on Friday afternoon or something. Not like that happen ever, right? Cool. Something else that I did with Marta, which is another person I mentor, and with Lisandros very recently, is improving the formalization on F-strings. And Lisandros then went ahead and did this fantastic work on T-strings that he presented yesterday. But one of the things that we discovered, like, F-strings were a bit of a hack in the language. So we put a lot of effort to basically format these F-strings and give it a proper grammar. So now you can do things like nest quotes, like you can see that over there, which nobody likes to put all the same quotes in the same thing. So this is an atrocity that now you can do. But now you can do things like adding new lines and things like that. So, like that is something that for me was interesting. And a lot of people think that, when you change things in CPython, we go to this room, right, and then we spend hours thinking, what is the best thing that we can do? But at the end, something that has been very clear to me when I was doing this keynote is that really the way I've been changing things in CPython is by working with friends, right? Like, and this is the thing, right? When we did this thing, I basically worked with to Liz and said, like, wouldn't it be cool if we do this? And it was like, yeah, and we did it. And now it's impacting millions of people around the planet, which is ridiculous because we are still clowns, But that is interesting, right? At the end of the day, if I could talk with the John Pablo thinking that science is everything and like that's what makes you happy, man, if I could only go back in time and tell them that, no, man, like friends will make you happy, and that's the most important resource that you will gather across your career, right? Like having the respect of your peers, for me, weighs much more than discovering the deepest secrets of the universe, right? So that's something that I have learned across the years, and this is a lesson I would like to tell you. Like at the end, even if you arrive to a super incredible place and then you have a lot of success, if you are alone and you don't have good friends, you achieve almost nothing. So like prioritize friends and whatnot. So this is Gukas and Victor Stinner in EuroPython 2 years ago. So Victor here, I put this image because Victor was the person who proposed me to be a core developer. Back in the day, the promotions were a bit harder because like everybody will vote, and if there is a single negative vote, you will not be a core developer. So when Victor proposed me, there was a single negative vote, and someone says, I don't trust this Spaniard. And Victor, that was the first time someone actually promote a core developer with a single negative vote. So Victor defied the rules for me. So he's also a friend now, and I have him very dear in my heart. Something that I want you to tell you that happened as well is that after the core developer sprint of last year, we were in a dinner with Guido, Emily, Yuri Seliman of Alessandros. And something that I like to say a lot in English is like, this is bananas. This is a sentence that I find very funny. And then at the point, like, I don't know who proposed that, but at some point someone says, do you know what you should do? You should give a talk dressed like like a banana. And then I said, that sounds very stupid, but yes, I'm in. So we went ahead and did it. This is some stickers that we were giving in PyCon US. Here you can see Yuri Selivanov, the very creator of Async.io and Async.away. He's Russian, so he's a very serious person, but I transformed him into this banana person. This thing went really far. You can see here Yuri and me giving a talk dressed like bananas about our work in Async.io introspection. But this is even crazier, because a surprise that happened after this talk is that Guido van Rossum, which is this guy on the right, also was dressed like a banana. So, you know, like when you're thinking about language design and all these people feeling very important because they work for Microsoft, this is the reality, right? Like, this is the banana people being stupid. So, you know, like, who will tell that small guy, like, doing science that he will, like, convince the creator of the language to dress like a banana? This is my real achievement, guys. Like, this is what I achieve. The corruption of people. Amazing. Cool. Something that I did as well, I'm super excited to talk about, is with my colleagues from Bloomberg, Matt and Ivona. So we work on PEP 678, which is a safe external debugging interface for CPython. And this is amazing, and it's coming in Python 3.14, and you're going to love it. So let me do a small demo of this. So here in the left, I'm going to have a small Python program that is doing some machine learning bullshit over there. And like now it's doing something weird. So I want to know why it's doing something weird. And before that, you will need to restart the program, maybe with debug statements and things like that. And that was very annoying to do. But since Python 3.14, you can now use this new thing called PDB -p. So now PDB will take a PID. So this is the PID of the program on the right. So you can do this. And in this very scary moment, type your password in front of everyone. And now, whoop, the program stopped. And then I have this PDB session on the right, and I can use it to inspect where I am. I can click next, and look at this. If I click next enough, the program will start to move. You see? It's moving a bit. It's changing lines. And now I can inspect, like, for instance, the local variables here. All the program on the right, so I can see all these stupid weights that are totally fake, because this is not a real program. And actually, I can inspect, I can check whatever is going on with my program, and then I can quit my session of PDB, and the program continues running. This is ridiculous. But because this machinery is very generic, something that you can do as well is that you can use this machinery not only to create, like, big boy debuggers, like this PDB thing, but to also alter the execution of the other guy for debug purposes. For instance, you see here, these logs that you are seeing is basically the Python logger on info. You see that here says info, right? So this is because it's logging on info. But this program has debug logs, except that I cannot access those debug logs because I will need to restart the program on the back, right? And that sucks because this program now is doing something weird. Maybe those weights are doing something strange. So something that you can do now in Python 3.14 is write a small script that will, I think I have it here. It's called debug something. Where it is? Here is activate debug. So this small script, what it does is that it will grab the Python logger and it will change the Python logger on the back. But how can you write this script on the other program? Because this other program is already running. So thanks to this new super cool interface, now you can basically grab the new function called sys.remoteexec, pass the PID of this guy, who we have at the beginning, this guy over here. And then you can pass this new script. So I say activate the bug. And you will see, as soon as I press enter, this guy is going to start logging on the bug. Is this amazing? It's super cool. Coming to Python 3.14. Wow. Cool. So I cannot wait for you to do a bunch of weird things and make all your coworkers angry because you're changing programs on the fly. You know, with great power comes great fun. Amazing. So let's go to the conclusion of the talk. So what was this weird thing? Do you remember this thing? All right. So I will tell you what this thing is. So this thing is the sound of the Python parser parsing a file. So how is that possible? So something I did is that I instrumented the Python parser. And I did basically every single time the parser tried to parse a rule, it will write to a file what rule it was, what token it's trying to parse, if it actually succeeds, and when that happened. So I used that, and then I basically put this thing on like a program that was running the entire thing. So I got this like mega multi-gigabyte file, and then I grabbed those information, again, the rule name and the rule and the token name and whatnot, and I transformed that to, like mapped that to musical notes in a normal scale, just like literally mapping. I didn't do anything special. And then I converted that to a music file using Python as well. So what you're listening there is literally the sound of the parser doing things. And it's so interesting because you can see how it's backtracking. every time it does this sequence of like, that is backtracking back again to a different rule. And this is ridiculous because, so I was hoping for nothing. I was hoping that when I was basically going to do this experiment, I got something like blah, 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 whatever, right? And it turns out that if you do the same experiment with the old parser, or even I try the Ruby parser, you will get nonsense. But this is very interesting because with the Perl parser, you get this stupid musicality. It's ridiculous. Like, this is like, I didn't expect this to happen. And even if you don't know how the parser works, you can almost hear the structure. And there is some weird art there. And this is something that caught my attention, and is the thing that sparked this whole keynote, which is that at the beginning, like, all this structure is quite beautiful, and this is something to actually try to follow, because instead of trying to, like, try to bootstrap your entire thing and like focus on the mathematical strictness of what you think is going to be great and follow your career and I must work at Google and get free lunch, instead of that, maybe a better strategy in life is to basically try the next thing and see if it works, and if it doesn't work, to move to the next thing, and failure is not failure. If failure just means try the next thing, right? And maybe across time, apart from creating these cool files, you can meet new good friends, like, I should have copied this at the end because it will be a nice end, but like Lisandros. And this is the lesson that I have here for you. Be clowns, try the next thing. A failure is not failure, it just means try something else. Thank you very much.
Good job, Lance. Oh, yeah, I'm full of emotions now. I don't know what to say. This was one of the best talks I've heard. I didn't even know you did this with the music, and it really sounds musical. So yeah, thank you, Pablo. I mean, like I said at the beginning, it's been a privilege to have you here at the first PyCon, and this was something I'll always remember. Thanks a lot. Okay, stay around. We're gonna have a short 3-minute thing just to assemble ourselves, but stay around. We're gonna do some raffles and then have some closing remarks. up next, it's going to be the closing session. But before that, we have something exciting for you. We're going to do a raffle. We have six books to raffle from Pact. Thanks, Pact. These are hard copy books. And then we have 5 more ebooks, and then we have 6 JetBrains licenses, 5 JetBrains licenses to raffle. So it's going to take a while, but see you around. So we're going to do it like this. We're going to press the button. If you're here and you see your name, come down and pick up your book. If not, then we're going to choose another person. For the ebooks and the licenses, we're going to do it and then email it out to the people that won. Sounds good? Okay. Yeah, give us the titles.
Yes. The first one was Clean Architecture with Python.
Okay.
The second one is Deep Learning with TensorFlow and Keras. Nicolas Konidis. Δεν είναι εδώ. Θα πάμε στον επόμενο, δυστυχώς.
Okay, more chances for you. That's okay.
Νίκος Λυκοτόμαρος. Είναι εδώ. Λυκοτόμαρος.
Okay. Go.
Ορέστης.
Yes, he's here.
The next is Python Machine Learning. Στράτος Τσιτούρας. Άννα Ελευθερία Κουκιού. People, why do you leave? Στυλιανή Κιωσέ. Είναι. Σουράς Κάρκι. Django 5 by example. So. Γεωργία. Okay. Learn Python Programming. Γρηγόρης Μαραβέλιας. And the final, it's Python Object-Oriented Programming. George Kiziridis. Αλέξιος Πολυχρονίδης. Μάριος Μάντζαρης. No. Yes. So I'm gonna spin the wheel 10 times, 5 for the rest packed ebooks and the rest for the 5 JetBrains licenses. So, 1. Two. Βγήκε οι δυο. Το ακυρώνω. Όχι. Εντάξει. Είναι και εδώ έτσι κι αλλιώς. And we're done, I think. One other one. And we're done. It's okay.
Okay, I promise it's the last time you'll see me on here, but I'll start with the closing remarks. So yeah, PyCon Greece, we actually did it. So a big round of applause for everyone. Yay. So a big thank you to our sponsors. We couldn't have done it without them, especially our platinum sponsors, Yodec and Elastic. We're really grateful for all the support, and we really couldn't have done this great event without them. A big thank you to our community partners. We had so many great events here, and it's all because of them, so we really want to extend a big thank you to them as well. We couldn't have done it with our great vendors as well. You've seen the venue, you've seen how the catering was handled, how the sponsor booths were handled. It was all amazing. So thank you to K Consulting, which is the firm that's been helping us with logistics and accounting, to Technopolis City of Athens, which is the venue, and Display Solutions, our sponsor booths vendor. A big round of applause for them as well. We had a lot of stuff. We had 3 amazing keynotes. Lais talked to us about her experiences and how they have shaped her life in the Python community, and consequently all of our lives in the Python community. That was amazing. Then Grigoris talked to us about astro stuff and how Python is used in astronomy and astrophysics, and all of the crazy approaches they are taking in that community, and that was amazing as well. And then Pablo talked about life and parsers and crazy things like that. Yeah, it was all amazing. I can't wait to rewatch the videos on YouTube, actually. We all started this with a documentary on Thursday. We had a preview of the Python documentary. It features a lot of stuff about the history of Python, and it's freely available on YouTube, so go watch it if you weren't there. We also had our Humble Data workshop. We had, if I'm not mistaken, 24 participants. Is that correct? Yeah, okay. 24 participants, and we had 4 or 5 mentors helping them out, and we got positive feedback about it, so it was really amazing. Thanks to everyone that participated, and of course, to the mentors and the organizers that organized it. Today, we had our amazing PyLadies lunch. the room was really busy, and we saw a lot of people getting there, a lot of participation, and that's actually really nice, because one of the main things we were thinking of when we started was try to get something running in terms of a PyLadies chapter here in Greece, and that was a really good start, and we really hope that this will keep on going forward. We had an organizers panel this morning. We answered some questions, then we answered some more, and we're always there to answer anything you might have for us. So find us on Discord, find us on LinkedIn, find us anywhere, and ask us questions and join us, because we need all the help we can get. Last night we had our social event. It was a blast. We ended up dancing, and yeah, that's a Greek thing to do, and we like to do it. But yeah, it was really crazy. The social event was sponsored by Yodek. Thank you, Yodek. I actually forgot to mention that the documentary was sponsored by eShare, so I'll mention it once more now. The documentary was sponsored by eShare. Thank you, eShare, for sponsoring the documentary, and thank you, Yodek, for sponsoring the social event. Yesterday afternoon we had the lightning talks. We had 7 lightning talks. We had some conference announcements as well. It all went great, and I hope you were here and you're already thinking of the lightning talk you'll do at the next PyCon or at the next conference you will attend. We also have some stats to share with you about how the conference went, and you can judge whether this was a success or not. So, ticket breakdown. We had 343 in-person attendees. Out of those, 68 were student and community tickets, and 42 were volunteer and fee-aid tickets. So, these are the numbers, and there's some more tickets that we didn't include here, but we can say that about 1/3 of the tickets were sold, and all of the rest were donated to the community or given out to other causes. So a big round of applause for that. We intentionally weren't collecting a lot of data for the registrations, but we ran some numbers, and we can say that about 25% of the attendees were from underrepresented communities in computing, and that's also something we're really proud of. This next number surprised me a lot. We had a lot of attendees in our live stream. We had something like 760 views on our 2 live streams from yesterday, and then we had about, I just saw Kali crying, and I'm gonna cry as well. Yeah, so a lot of attendance on YouTube as well. About our program, we had 151 proposals. It took about 718 reviews to go through all of those proposals and actually select the talks. We ended up with 40 speakers in 31 talks and 5 tutorials. So yeah, that was a great number as well. We couldn't have dreamt of a better number to have more than 150 proposals. Lais talked about financial aid yesterday. We ended up giving out 5,590 euros for financial aid. That included free tickets to participants that couldn't afford the ticket, and also accommodation for some of the the people that applied for fee-aid. So that was 13 attendees and 6 speakers out of 39 applications we got for financial aid. Most of you might not know about this, but behind the sponsor area, we actually had childcare as well. This is how it looked. The reports we got is that the children had fun. Is Eleni around? Okay, Eleni is an organizer, but she's also a mother, so she has some stories to share.
I'm very glad being part of this amazing community. It was an amazing experience that I was able to share with my daughter. So it wasn't just practical to have her close by me playing. It also was an amazing experience share this amazing community spirit with her. And it was very glad having her first visit in an auditorium, and today she was so excited and she wanted to join me again. So for me, this is the most important, having her in a place with amazing people, and not just bright minds, but amazing people. Thank you.
This is amazing. You can see here a picture of her actually taking a Polaroid of the people that were responsible for childcare. I just went back there to check whether we had any COC stuff, and I'm happy to report that we had 0 incidents. This year there was no reports up until now. We're going to have a more elaborate report coming out in case we do get any reports in the next days or weeks. That's it for me. I'm going to give it to Fanis now to talk a bit more about the organizers, the volunteers, and everything else.
Stay on stage. Stay on stage. Stay with me. I was here. First of all, it's time for bad English and Greek accent. I'm not like him. So yeah, I'm also the person that I took some notes because what I will share is also important, and I won't like to say to forget something. So Lysandros, can you help me? And now you can compare me to our last keynote. So I would like to ask, first of all, did you have fun? I think that now is the time that all the smiley faces, all those people that helped us, come on. Yeah, that's me. And now she comes and runs.
There you go. Oh, it's okay.
We don't need you. Yeah, it's better.
Huh?
Yeah, yeah. Okay, thank you. So now I will use this one. So, what else? Yes. So it's the time that all the smiley faces, all those people that we had with us and they helped us all those time to come on stage. So if you hear your name and you are here, and of course if you want, you can come on stage. It's your time to be recognized. And after the event, I have a letter to give to all the organizers, so come and find me. I think, Lysandros, it's our duty, first of all, to give the biggest hug to those people. Share a bit of more info about them, all those superheroes that worked non-stop all those months with us, and gave us this incredible vibe, and it's sure that we couldn't do it without them. So this is not the list of volunteers, but now this is the list of volunteers. Yeah, those people, some of them worked more than 8 months to have all this done. It might seem to be 2 days, but for sure, for us, it was longer. First of all, we have Alexis. Alexis worked on the operations team. I would like to highlight the smile and the natural guidance that he has, and always filled me with joy. So, Alexis, I think you are here. Yeah, come on stage. So now Panagiotis has asked me not to pass this not to pass Petros the Pelican, because that's it where the camera stops. I told it, like, okay. And it's recorded. So next we have Antonis, who unfortunately is not with us. He helped us with sponsors. He did a lot of work and gave us a lot of experience in a moment that we were a first-year event. We didn't have any sponsors, so any money. And his experience with the Greek market was very important for us to find leads. Then we have Chuk. I would like to thank Chuk for joining us. Yeah, I have to. For joining us and help us with Humble Data and, of course, with our COC team. The experience that you gave to the team was incredible. So thank you for that. Then we have, of course, Eleni, again. Eleni, apart from the childcare where she made sure that all the kids were okay, that's, for me at least, it was very important. She was part of our design team, and pretty much all the designs that you see, all this lovely result on the website or here is her work. Now, I think we change the conference and we go to different conference. So now we have the PyCon George. The next 5 minutes I will talk about Georges. So the first George, or the less serious George, is George Isopoulos. So now it will get emotional for sure. George was the main coordinator for on-site volunteers. I know him for quite some time. I think he's the best person to do that because he spent hours and hours on that to make sure that all the on-site volunteers were okay, that they had everything that they need, and especially the ones that they did it for the first time. And I think I would like to thank you, give a big thank you, even though I cannot see you and actually speak to the microphone. So the next one is George Margaritis, or the more serious George. So actually, George is the person who dropped the database on a Sunday afternoon. Panagiotis knows better. He was also part of our communication and sponsor team. He always has an eye on everything. He has the most valid points. And of course, the amazing results that we had for the conference in general about tickets, about everything, is part of it. It's part of the communications team and the social media channels and everything. I truly believe also in his potential in the community, not only here, but in general. The last George, or the other George, is George Chalikopoulos. He was part of our communications team, and I would like to quote, I think that I heard today. It was about no matter the accomplishment, like even if you have the biggest accomplishment by developer for your product, if you don't have a marketing expert, it may end up to nothing. And I think George was exactly that for our team, helping us with the communications. So next one is Kali. So if you have the relationship with the audio, it's easier. So now, Kali was the soul of the main organizer of our lovely social event. She's also one of the main contributors of the website, and I truly believe that her passion, her constant smile, maybe she's crying now, she has a smile, and her positive energy, you saw that, kept us going even if in the roughest terms. Next, we have Katerina Kanelopoulou. Katerina, unfortunately, not here, but she was also a main contributor of the website, and I hope that she will be here next year. Next is Katerina Xagorari, another Katerina, who's also not here, so maybe is the name. Really helped us with this awesome page that we did for the Athens and everything that someone can join, especially for the folks who came from abroad. Yeah, again, I would like to have her here next year. Then we have Cleopatra. Where's Cleopatra? Is here. Cleopatra joined us and helped us a lot with the financial aid team. Her contribution to this team made sure that the event was affordable and inclusive for everyone, so everyone can join. You saw the stats and how many people joined us, and it was part of her work that she made sure that everyone was okay with the financial aid. Then I think it's a very good friend, Isla Carvalho. I mean, you gave the best keynote talk, like I cannot say more. So she was here to help us. Okay. So she was here to help us all the time and did a lot of things. She instantly accepted the keynote, of course. And in every turn she gave us advice, and in the more serious part of this, she really tried to make our community diverse and inclusive, especially in the start with Lysandros when we didn't have any female organizer. I will leave Lysandros and Panagiotis Kyrillos for the end because I'm sure that it will get emotional for me. Then we have Konstantinos. I'm not sure if Konstantinos is here. Yeah. Thank you, Konstantinos. Who helped us. Who helped us with the code of conduct and made sure that everyone follows it. You also saw the stat that we had 0 incident. Because for us, this is the basis of everything, that this process and this documentation, this code is followed. Then we have Michalis. Michalis helped us a lot with the operations team. And if I'm, you are coordinating the photographer, but if I'm not wrong, you joined us after a lightning talk that you gave in Dublin, right? Yeah. About PyCon Greece. So next one is Olga. Olga was a part of our program team, helped us with the PyLadies lunch, Humble Data, and of course she was the soul of the documentary event, as she handled everything alone, pretty much alone. The thing that I think that Olga brought to our team is her experience and this lovely energy, and I'm sure that this will inspire more female organizers or more organizers with a more diverse background to join us in the future. Yes. Thank you, Maria Jose. Next one is Panagiotis Kias, and the truth is that, yes, who is? I mean, truly, I could talk a whole day about what we did together, because we were very close this year and we did a lot of things together. He did an amazing job with the sponsor team, an amazing job with the financial team and the operations team. All I could say now for Panagiotis is a huge thank you for everything, and I gave you a big hug for the passion and the love for the community. Then we have Persephone here. Who is the soul behind the Discord board. And a strong ally, of course, for diversity and inclusion. Here I would like to say that I'm honored that I have worked with you. And I strongly believe that if we didn't have Persephone on board, PyCon Greece could be kind of a darker place, for sure. Always. Then we have Piotr. So Piotr is one of the 2 superheroes, and he came all the way from Krakow, and actually in a moment's notice to help us. The whole effort, you need to know the whole effort, the cameras, the videos, the stream, this whole production that you see is a volunteer-led effort, and if you ask me, that's insane. It's a big achievement. The experience that these friends first and experts second gave made it possible, so we have live streams, we have recordings, we have everything. The other superhero for our AV is Raquel. The biggest. She cannot join us now because she handled the camera. Yeah. She came all the way from Scotland. And I owe a huge thanks to Raquel for, apart for her work for the AV, she was really my mentor all this year, giving me advice, making sure that I was strong and good to continue. And please give a big applause to her because she deserves it. Next, we have another lovely human, it's Spiros. I'm not sure if Spiros is here. No, okay, but we can still applaud. Spiros helped us a lot with video editing and also the website. Then it's me and... no. The last one on the list is Vasiliki. I need to say it directly to you. It was an honor working with you all the year. And thank you for being the first female organizer for PyGreece. Thank you for being there every moment to ensure that everyone follows the COC. And the child care that it was perfect, the financial aid was given to the most possible people. And most of all, thank you for being so sensitive about the volunteers, their workload, and their well-being. Now, I would like to ask for another huge applause for the next organizer. This is Panagiotis Kyrillos. So, say something.
Hello.
So, Panagiotis is the person. Don't one moment. Come on the front. Like, don't be in the background. Panagiotis is a person you may notice behind the scenes always, making sure that everything with the AV is okay. He's also the lead for the design and the website, and he did. I cannot really list the things that he did all the year. It was really an honor for me working with you again because we have worked in other projects in the past. His contribution is literally everywhere. His big smile, yeah, is everywhere. And his big heart is everywhere. As Panagiotis is behind all those lovely images that you see, all those lovely animals and stuff like that, Lace knows. Yeah. I would like to say that thank you, Panagiotis, for sharing with us your world and making and inviting PyCon for this in this lovely universe of lovely creatures and dreamy landscapes. And, yeah, come on. You can go outside.
Can I thank you too also, because you haven't said anything about yourself.
I will say things about you too. I learned that, I heard that it was a panel before.
Yeah, shall we say something about
I need to close it and then?
Close it.
Yeah, because I will start crying. Yeah. So this is, here's Lysandros, and you know, I think it was pretty clear in the panel. We started this together, and we both know how difficult it was, in the beginning and all these years. Lysandros, apart from being an admin of the non-profit that we run and runs also this event, was also part of the program team, and he managed our Discord server and many, like Panagiotis, many other things. But I would like to highlight this. I would like to say thank you to Lysandros for keeping up on every difficult turn. Thank you for sharing with me the dream of a unified and active community in Greece of Python. Thank you for sharing with me the dream of the very first community-driven and volunteer-led PyCon in Greece. And it was a privilege working with you, and most importantly, learning from you. That's it. We did it. So, I didn't cry. And now is the time for all the lovely, yeah, I need to do that. And now is the time for all the lovely on-site volunteers and some friends like Aris or Ege to come on stage and who helped us with the event. Those amazing people took care of you during the event, and without their contribution, it couldn't be possible to do the event. Mostly because, I would say, of this insane blow of positive energies that they brought in the days of the event with us. And I hope that for the years to come that they will also be organizers. Also, I would like to say a big thank you to Vasilis and Nikos, our photographers, and please a big applause for them. And the work they did, you have to know it was also for free and volunteer-led. All the work was amazing. So please let's have on stage Elias, Lazaros, Krepas, Kostadina, Christos, Marcos, Kyriaki, Irini, Stelios, Alexandros, and of course Ege and Aris. I told you we cannot fit in this area. We need to go there. Where is Panagiotis? So that's a wrap. That was the very first ever PyCon Greece, and I hope you liked it. And we would love your feedback. Last and most important, we need your help. So if you want to help us, please reach out to us. Now you know us.
Yeah, it's hard to talk now, but Fun has talked about all of us.
We can wrap it up. He will start complaining.
Hello. Yeah, and all of this work, I have not prepared anything, and all of this work also was coordinated by Fannis. Everything was, I don't know, passing from his, checks. He was checking all the, he made the budget, he made he made everything, actually. He was just telling us what we needed, we were kind of delivering. So yeah, the most important thing is fans here. Thank you. Thank you.
I think it's kind of true to say that there were like 10 fantasies around and doing all sort of stuff. That's fairly, that's fair to say. It felt like there were 10 of you. I mean, we were doing things and then you were everything. Yeah, and the fact that he didn't say anything about himself shows how empathetic and what a leader he is. So let's all look up to him.
A group photo?
Πάμε μπροστά από το τέτοιο και να ανάψουμε πάνω.